Hello, hi, namaskar everyone. My name is Deependra and today let's get started with continuity and differentiability. Remember that in the last slide we have covered limits completely. So this is a one shot where in the previous one shot we have done limits absolutely totally. And in today's one shot we'll cover continuity and differentiability. I hope you all can hear me. My voice is clearly audible. I am clearly visible. The screen you can see properly. Everyone, just give me a quick response in the comments so that we can straight away get started. Am I clearly visible and audible, students? So once again, hello, hi, namaskar, good evening, everyone. We are getting started with continuity and differentiability. Before we get started with continuity and differentiability, today we'll be conducting a lot of polls. We'll be conducting a lot of quizzes. To participate in those polls, what you can always do is you can simply have this application PyLens installed in your phone if you're watching it on your phone from Google Play Store. If you're watching it on laptop or browser, you can download it from Chrome Play Store. Sir, what is the advantage of it? Merely participating in polls, is that only? No, no, no. You really don't have to do that in that case. It has its own advantages. For example, let's say you want to generate a quiz on any random video you're watching on YouTube. You want to generate a mind map or short notes or PDF related to any random video you're watching on YouTube, or let's say PYQs of that topic which you're watching on YouTube, any random video I'm saying. You can get all of this done with the help of PW PyLens application. I hope you got my point, which you can download from either Google Play Store or Chrome Store. In the last lecture, we have done the chapter or the concept limits. And today we are moving towards continuity and differentiability. So what you can start doing is you can start solving previous year's questions of limits so that you can get more clarity on this concept. So limits you can start solving specifically the previous year's questions, but technically it is merged with continuity and differentiability. JEE Mains also don't ask it solely questions based on limits only. So we'll be facing questions from continuity and differentiability altogether. So today we'll get done this whole thing and then you'll be able to solve a lot of previous year's questions. Everybody with me so far? Any concerns or queries if you have? So today, what are we starting? Today, I'll begin my discussion with continuity. We'll understand what is continuity, its definition, its various types, and then different theorems based on which questions are asked. And once we are done with sufficient practice on continuity, we'll move towards differentiability. Again, its types and all, and then different theorems which you need to understand on differentiability. And again, once we are done with apt or sufficient number of questions, we'll move towards the next part, which is the more practice. That's the flow. Yes, my friend Bolt Gaming, you should, I will say, because in this series, we are getting all of these chapters done. Chandresh is asking, sir, is it possible to crack JEE Mains in 6 months? Yes, Chandresh. Do visit our videos section. In that section, I have recently recorded or released a lecture titled as How to Cover Your Backlog, which actually covers exactly what you're asking. Is it possible to crack JEE Mains in 6 months? Yes, Bald Gaming. Right now, our complete or major or more focus is on theory and practice for JEE Mains and Advanced both. But later on, gradually, we'll bring practice-oriented sessions as well, where we'll be dealing thoroughly and solely with a lot of JEE Mains and Advanced specific questions. I hope I'm clear and visible and you are understanding all what I'm saying. So you know the concept of limit, don't you? So if you know the concept of limit, you can understand the concept of continuity very easily. Sir, how? Continuity is actually an extension of the concept of limits. Sir, what does it mean? Let's say you are given a function. You are given a graph. This is how a graph looks like. Now, let's say at any point, I want to check its continuity. So how do we check it? Can somebody write the condition in the comments? Although it's already visible, but still in your own language, how do you? I have covered everything in that video, Chandresh. I'll request you to watch that video. You'll get a lot of insights and details. In short section also, I have given you a timetable as well. One of the latest shorts, if you watch on our channel, PWJ English, you will get the idea for the timetable as well. Don't worry. Bold Gaming, fortunately, whatever you're asking, whatever you guys are asking, I have recently recorded the same videos on that. So I have just recorded a book for video for books as well, which will get released very soon. So you'll get an idea on that as well. Absolutely, Chandresh. So the approach here is simple that, sir, if you want to claim that there is a function which is continuous at a certain point, let's say this is the point A. So this is a value of x which is A. So if I want to check whether it is continuous or not, so what I'll do is I'll check its left hand limit, I'll check its right hand limit, and I'll check its value. So if the LHL, if the RHL, and if the value of the function, they all are same, then only I'll say that the function is continuous at that point. Good to have you, Vansh and everyone. Good to have you. Amazing. It's really nice. And if it's not continuous, it breaks. Tanvi saying, sir, can we see this lecture for clearing all the basic concepts? Absolutely, Tanvi. This is for that only. So shall we resume, everyone? Are you all there? Staying focused. So this is how you define continuity. Sir, what does it mean? Are you saying that they all should be equal? Yes. What if, sir, one of them is not equal? One of them is not equal means what? One of them is not equal means either LHL is not equal to RHL, but RHL and F of A are equal. Or LHL and RHL are equal, but F of A is not equal. Or RHL is not equal to F of A, but RHL and LHL are equal. So there are multiple cases. I think I repeated one case twice, but I hope you're understanding. With these possibilities, when we want to ensure all the three things, LHL, RHL, and the value of the function to be same, I can create a lot of cases where discontinuity may arise. So, sir, before discussing anything, shall we discuss or talk about discontinuity? The duration of this lecture will be around 3 to 4 hours. I'll try to bind it around 4 hours, considering the breaks. Of course, we'll have a break meanwhile to have the dinner, and then it will go smoothly. So shall we resume, everyone? First of all, let me bring different cases, then I'll come to this scenario. I am saying that there can be multiple scenarios. There can be multiple scenarios. Look at this scenario, first of all. In this scenario, what is happening? I hope some of you can tell me what is happening. Sir, in this scenario, what is clearly happening is around 1, RHL is taking you towards 2. Around 1, LHS is taking towards 2. But at 1, the function is not even defined. So f of 1 clearly does not exist. So in this case, this is a scenario where LHL and RHL both are equal, but the function, the value of the function at 1 does not exist. The value of the function at 1 does not exist. So there is no point of comparing the value of LHL and RHL with f of 1. What does it imply? Does it not make you understand that, sir, yes, we can clearly notice that the graph broke. The function breaks at 1. LHL was taking me towards 2, RHL was taking me towards 2, but at 2, what happened? The function did not exist. So if the function doesn't exist at this point 1, which should have been 2 technically, to make it continuous, it is clearly not there. Definitely, Raja Rani, definitely, I'll be really happy if you do so. So I repeat my point very clearly here. Pay attention, everyone, that here, in order to ensure that it does not lose its continuity, f of 1 should have been very well defined, and it should have been very well defined as LHL and RHL, which should have been 2 here in this case, which is not happening. So this is clearly a case of discontinuity. But sir, what kind of discontinuity? I'll say this is a missing point discontinuity. Sir, why missing point? Because this point is missing. So sir, is it a removable discontinuity? Can we remove it? I think it is in your hands. How are we going to remove it? Sir, we can remove it if I define f of 1 as LHL and RHL. What is LHL and RHL? That's 2. So if f of 1 is defined as 2, this discontinuity will be removed and this function will become continuous. So with this redefinement or redefinition, this missing point discontinuity can be removed. Everyone understood this part? Shall I move towards the next portion, everyone? Everyone with me? Any confusion so far? Sir, another type of removable discontinuity is isolated point. So there is this thing that point is not missing here as the previous case. No. Here in this case, LHL around 0 is taking me towards 1. RHL around 0 is taking me towards 1. So in this case also, sir, LHL and RHL luckily both are same. But sir, in this case, if you look at f of 0, f of 0, that is clearly not 1, that is 0. So f of 0 is 0. Shubhash, as I have told you in the beginning, this session may last for 3 to 4 hours. So if it is 6 o'clock right now, I may be binding it around 10:30, 10, 11, between 10 and 11. So I am saying that f of 0, how do we take f of 0 as? So f of 0 I'll be defining as 0, let's say, if it is defined as 0. So there I am seeing a problem that LHL and RHL are same, but they are not equal to the value of the function at this point. And because of that, the discontinuity is arising. Because sir, we are approaching value, but the graph broke here. So can we remove this discontinuity? Yes, if I redefine this function. If I again redefine this function where I give the redefinition as that f of 0 instead of 0 should be 1. So if f of 0 instead of 0 converted into 1, I think this discontinuity will be removed because now the function will be defined at this point, and because of that it will lose its discontinuity and it will become continuous. So what kind of discontinuity it is? Isolated. The point was there, but it was isolated. So if I bring it here, it will become continuous. Everybody got it? Any queries or confusions if you have, please ask. Then you have non-removable discontinuity. Imagine this curve. Let's say we are given a piecewise definition here. Piecewise definition means, let's say the curve f of x is defined as two definitions it takes. One definition it takes is minus x plus 2 for all the values of x which are less than minus 1. And it takes other set of values which are x squared for all the values of x which are greater than 1. So if I club this data, if I, draw the curve. So I hope you are clearly noticing that sir, minus x plus 2 is clearly a straight line. For all the values which are less than minus 1, it is a straight line. But after minus 1, for all the values which are greater than minus 1, I see a quadratic which has vertex at 0, 0. So this is how this piecewise definitions graph will be drawn. But sir, now what? If I ask you about its continuity at minus 1, how do we check it? So continuity here at minus 1, if I wish to check, I'll check LHL. So if I approach minus 1 from left hand side, I'm approaching 3 from left hand side. If I approach minus 1 from right hand side, I am approaching 1 from right hand side. So in this case, sir, forget about the value of the function. You are clearly noticing that LHL and RHL are not equal. Are you noticing this, all the participants? Yes, I hope you're getting it. So what I'm suggesting here is that LHL is taking you towards 3, RHL is taking you towards 1. So I am clearly saying that LHL and RHL are not equal, although RHL and the value of the function are same. I repeat, RHL and the value of the function at, there is minus 1. Yes, I made a mistake. I'm really sorry. And somebody highlighted it. Vijay, thank you so much for that suggestion. Thank you so much. So I'm saying value of the function at minus 1 and RHL are same, but LHL and RHL are not same. And look at the simple, clear observation here. No matter what I do, I won't be able to remove this discontinuity, because here there is a jump, there is a gap. You just cannot pull it here, or you just cannot shift it there. This is not how you can redefine these functions. So there is a problem. What problem, sir? There is a jump. Although this is a finite jump, 1 and 3 has a difference of 2. So there is a jump of 2 units. There is a jump of 2, which is a finite jump. But still I can see this definition here, this function here cannot be made continuous. Have I made myself clear? Did you all understand this? Everybody got this clear idea? Any confusion so far regarding finite type? In non-removable, there is one more type which is called infinite. Infinite type discontinuity, which is again asymptotic type discontinuity, which means here there will be discontinuity where there is a jump, but the jump is of infinity. In the previous case, jump was finite, 2 units. But sir, what if this is the graph y is equals to 1 by x? I hope you know that. Reciprocal function, everybody knows that, don't you? So if 0 is approached from left hand side, sir, your curve will be going towards minus infinity. If 0 is approached from right hand side, sir, the curve will be going towards plus infinity. So there is clearly a jump. I mean, LHL and RHL are clearly not same, and there is a jump of infinity. So I repeat, in this case, first of all, LHL and RHL are not same. And if you ask me f of 0, then I'll say it does not exist. So what's the problem? All of them are not there. I mean, the worst which could have happened has happened here. LHL and RHL are not same. And along with this, there is one more. That f of 0, which is even, does not even exist. So in that case, clearly I see the possibility, or rather the direct sense of discontinuity. What kind of discontinuity? Can you remove this? Of course not. This is non-removable. And there, the jump here, from here to here, if you see the gap, the jump is infinite. So we call it infinite type discontinuity. Asymptotic, why? Because there this line, y-axis, which is x is equals to 0, is behaving as an asymptote. Somebody in one of our sessions was asking, sir, maths does not have emotions. I told them, look at the example of asymptotes. This curve in this straight line, they keep getting closer, but they never touch each other. They touch each other at infinity. Isn't it emotion? Yes or no? So if I continue further, what I tell you next is that infinite type is amusing. But if I talk about oscillatory, sir, what is oscillatory? Can you explain this? I will take a very beautiful example here just to make it more understandable. Here comes, let's say, a tool which I'll use to explain this. Everyone, stay attentive, stay alert. Something really good will do here. Let's say I have this thing over here. Just give me a moment, students. I will be drawing a curve which I'll be saying as y is equal to sine of 1 divides or 1 divided by x. Can you see the beauty here? Can you see the beauty here? Can somebody see the beautiful thing happening over here? What is happening to this x? Forget it. Anyways, are you noticing something? Are you all noticing something very interesting, something very amazing? I am saying this is the graph of sine 1 by x, which looks continuous up to an extent. Because, sir, don't you think that this is clearly continuous? Although there is some oscillation here, and then again it got continuous. Let me zoom it in a little. So if I zoom it in a little, this is how it looks like. Sir, look at the beauty of mathematics here. Although it is oscillating a little, but this is still continuous because the graph is going smoothly. But I hope your brain, your intelligence must have already told you that, sir, 0 will create some problem. 0 will create some problem. 0 will indeed create some problem. Why would it not? Because if I keep zooming it in, I hope you're seeing it. There is a student in our class in Laksh batches. When I was zooming it in that batch, he was he puts a comment that show us atoms today, sir. Take it to the atoms today. So I hope you're realizing the more you zoom it in, you see oscillation happening so terribly. You see that, frequency increasing so badly that you will see that limit is clearly not defined. LHL and RHL. The slightly you move towards 0, it shifts, it jumps. RHL also goes like that, it keeps on jumping. And 0 is not even, the function is not even defined at 0. So at 0, the graph breaks. That's oscillation. Oscillatory type of discontinuity. Did you realize it? The more you zoom it in, the more problem you will see. Are you seeing the problem here? The more, compactness. So you may say that the function is continuous, or see the graph is there. You're not understanding. You're not understanding. The more closer you go towards 0, the more oscillation it takes. So it may look like continuous, but it has a certain problem. Everybody understanding my point? So what did I just say? I said a very beautiful direct fact that this function, for example, sine pi by x, is clearly a kind of a function where at 0 or around 0, it oscillates so terribly with so high frequency that even limits are not defined. Value of the function you forget. So if limits don't exist, which means LHL and RHL around 0 are not same, we'll say that it is again discontinuous. Did you all get it, or shall I repeat it? All the participants. So if I could culminate or summarize all what I've given, I have given you this data. That we have discontinuity of the following types. Removable, where there is a missing point, which means if the graph goes like this, remove a missing point. Isolated means what? This is how the graph goes like, and the graph is defined like this. I could remove it. But finite type means what? This is how the graph is going, and then it is going like this. I simply cannot remove this jump. And let's say infinite type means what? Let's say this is the asymptote and the curve is going like this. So it is clearly breaking, cannot be removed. Oscillatory, I hope you have understood by the example of sine. Yes or no? So these are the different types of discontinuities which we have just covered. Everyone understood it? Yes or no? Along with this is the major part regarding continuity. I'll summarize as. So my final summary will be this. If you want to notice or observe or highlight that a function is discontinuous at a point. So following of these things could have happened, which means, sir, LHL and RHL exist, but they are not equal. Sir, LHL and RHL exist, they are equal, but they are not equal to the function. Sir, LHL and RHL, whatever is happening with them, but if the function is not defined at A, it will be discontinuous. Sine 1 by x, it was not defined at 0. Or the next case where at least one of the limits does not exist. I hope you're clearly noticing, for example, this case. Yeah. For this part, for the fourth part, let me do it here. The fourth part, if I could explain to you, how is it happening? Let's say this is how y-axis and x-axis are placed. Let's say this is a line parallel to the y-axis. So let's say this is how a curve is going. And then it takes values like this. So I hope you do realize, even if it takes a value from RHL and this, I hope you are seeing RHL is going towards value of the function. So value of the function and RHL are same, but LHL is clearly going towards what? Plus infinity. So that's clearly a case here for the fourth one. Everybody understood it, all what we have done so far. Any queries or confusion if you have, please ask. And if you have gotten it, let's try and answer a question with this. Everybody with me so far. A very good, a very insightful, and a very decent and a direct question based on the concept of limits. But before I do it, you can also do it along with me and parallel simultaneously. Let's do it together. Everyone, are you all set? So how do we solve this question? Everybody. I am told few things. Let's focus on few things. What are we told? Fx is a continuous function. So we are told this is a continuous function. So if it is already claimed in the continuous function, can you help me? What do we mean by continuity? Sir, continuity means three things. LHL, RHL, and the value of the function should be same. Let's do that. We are told that this function is continuous. So I'll take that advantage. For all real values of x. So sir, this is a continuous function for all real values of x. Okay, beautiful, interesting. And it satisfies this kind of functional equation, let's say for a while. This kind of equation I'm given, which is satisfied by f of x for all x which are real. Okay, that's pretty cool. And then they are asking you the value of f of root 3. Okay, sir, let's try and do it. How? Let's work it out. So if I rearrange this whole question, so what do I get? Okay, let me rearrange it. So if I start rearranging it, let me put the terms with fx together. So x square is there, I'll keep it like that only. Minus 2x is there, so I'll keep it like that only. Plus 2 root 3 minus 3 is there, so I'll keep it like that only. Plus 2 root 3 minus 3. Everyone comfortable with whatever I've done so far? But sir, there are two things which you have missed. This part, which is minus root 3 times f of x, and this part, which is x times f of x. I hope no confusion on whatsoever I've done so far. X square minus 2x, 2 root 3 minus 3, and then you have minus plus f of x, x f x, and this minus root 3 f of x. Everybody got this? Comfortable? And by the way, do let me your answer. What do you think could be the answer be? So the next thing which I suggest you to do is that here, please pay attention. Can I take this whole thing on the right hand side? So sir, if you take it all on the right hand side, it becomes positive, and this thing over here becomes negative. Sir, one more thing you could have done. What? I could have taken fx common. So if I take fx common, I'll be left with root 3 minus x. I'll be left with root 3 minus x whole times f of x. Can I do so? Everyone getting it comfortably? One last step I wish to perform, if you all allow me. What is that? Root 3 minus x can be brought here. So ultimately, I'll be receiving f of x as a quadratic in the numerator, which is x square minus 2x plus 2 root 3 minus 3 whole divided by root 3 minus x. I hope I have not done any mistakes. You're getting it comfortably. All the participants, yes or no? Yes or no? So one of the ways is factorization. This is a quadratic, splitting the middle term. Factorization can be done. One factor will definitely get cancelled by it. So why are you saying it so confidently? Because we are told that this is a continuous function for all x. So if it is a continuous function for all x, I see f of root 3 to be a 0 by 0 form. Don't you see this? F of root 3, if I try to figure it out from here, f of root 3 will be, I hope you are clearly noticing, 2 root 3. So 2 root 3 cancelled. Root 3 square is 3. So 3 minus 3 are getting cancelled. Root 3 minus root 3. So this is clearly a 0 by 0 form. If I try to find by this logic, f of root 3, I'll see to be getting converted into a 0 by 0 form. Which means what, sir? Root 3 satisfying numerator, which is a quadratic, which means x minus root 3 will be a factor of it. Which means x minus root 3 will get cancelled from the numerator and denominator. By doing so, I can get the answer. Sir, instead of factorization, can we do something else? You know that approach. Can somebody quickly tell me in the comments, the moment we get either a 0 by 0 or an infinity by infinity form, what do? There is a short trick, right? And you all love it. What is that? Anyone, quickly. I hope you do remember that here I'm told that f of x as a function is continuous. It is continuous. So, sir, if it is continuous, that means its limit at root 3 will be defined. So if I do limit when x approaches root 3 on f of x, it should be equal to f of root 3, because we are told it is continuous. But sir, if I apply limit, I am getting a 0 by 0 form. No problem. Even if I'm getting a 0 by 0 form, this question can still be solved if you use the basics which you know. Sir, what are those basics? One of the methods is factorization. The other method is L'Hopital. Brilliant, Vijay. Keep it up. Really nice. And you have gotten the answer. That's amazing. So if I do limit x approaches root 3 on f of x, I'm getting a 0 by 0 form. So to deal with 0 by 0, L'Hopital, x square's derivative is 2x minus 2. Yes or no? 2 root 3 and 3 are constant. So they'll become 0. Yes or no? Everybody getting it? Limit x approaches root 3. What did I do? I'm applying L'Hopital. So this x square becomes 2x in the numerator, minus 2x becomes minus 2 and differentiated. 2 root 3 and 3 are constants, their derivative will be 0. No, they are not. Okay, anyways, you take it that way. It's good, Nikhil. It's easy, I think. And in the denominator, root 3 minus x, root 3 is 0, minus x derivative is minus 1. Yes or no? So I think if I substitute root 3 here, 2 root 3 minus 2, but negative will say 2 minus 2 root 3. So my final answer will be 2 minus 2 root 3. How many of you have gotten this? How many of you have gotten this as the answer? Let me know in the comments. I'll be really glad and happy. Vijay, I think, has gotten it. And Vijay, I'm sure you're using your own sincerity, not using AI. You're doing it genuinely. Everybody got it. Any confusions? Did you all understand? Good question it was. Decent, direct, standard question it was. If you simply know the concept of continuity and limits, you would be able to crack it. Now, there is a concept of directional continuity as well. Let me just introduce it and then we'll move towards different categories as well. Directional continuity here means that, let's say here at A, what I'm noticing it, that sir, LHL at A and the value of the function at A is same. That's good, Shubhash. But sir, RHL is not same. So if LHL, RHL and the value of the function is same at A, it will be continuous at A. But sir, at A, we are noticing the left hand limit at A and the value of the function are same, although it is not equal to the RHL. Fine, perfectly fine. But even if they are same, LHL and the value of the function, then we call it left continuous. Then this kind of continuity is called left continuity. It means it is not continuous here, but it is left continuous. From left hand side, if I see it, imagine it is like this, that let's say, imagine it in this manner, that let's say here we have the graph drawn somewhat like this. If we have the curve somewhat like this, and I just ask you about this part here. Now, what will you say? What will you say about this curve? Is it not continuous? This is continuous. So if I ask you to just look at it from this to this, it is continuous. I will getting the meaning of left continuous and right continuous. So when I talk about continuity in interval, I'll be talking about left continuity and right continuity. I hope the same thing is happening with right continuity as well. So what do you mean by right continuity? Look at this part again. Right continuity would mean what? Right continuity would mean, let's say here, just let me remove it. Right continuity would mean, let's say there is nothing like this here. There is nothing like this here. So here, let's say I have a graph like this. I hope everybody is very clearly noticing that, sir, around B, RHL exists. Around B, the value of the function exists, which is f of B. So, sir, at B, I can notice right-hand limit and the value of the function are same. Sir, what about LHL? Why would I look at LHL? Because there is no point on the left of it. So why would I look at it? So if I just look at these two values, are they same? Yes. So I'll call it right continuous. I'll call this kind of continuity to be right continuity. Although the function may not be continuous at B, because on the left of B, I don't see anything. But at B and on the right of B, there is clear similarity. RHL at B and the value of the function at B is same. It is right continuous. Did you all understand why am I introducing the concept of left continuity and right continuity? Because let's say, this is the very simple example through which I've tried explaining it. But let's say in some case, I need to check the continuity in an interval like this. So let's say this here is a point A, this here is a point B. So I want to check its continuity in open interval A to B, or let's say closed interval A to B. So I want to check its continuity in closed interval A to B. I want to check whether fx is continuous or not for all the values of x which are in closed interval A to B. So what are we going to do? Sir, if fx is claimed to be continuous in the closed interval A to B, so it should be continuous at all the points between A and B. But what about A and B? At A and at B. Sir, at A and at B, all you need to do is, first of all, check the value of the function at A and just check the RHL only. So at A, what I'll check is, at A, I'll check the right continuity. Getting my language, everyone? And at B, again, I'll say, find the value of the function, which is f of B, and check its LHL, which means here, I'll check the left continuity at B. So function should be continuous at all the points between A and B, but at A, it should be right continuous. At B, it should be left continuous. Is there any point of checking LHL at A? Is there any point of checking RHL at B? I hope it does not make any sense. And if I check these two values, right continuity and left continuity, and of course, all the points between A and B, if it is continuous, I'll claim that fx is continuous for all the values of x between A and B if these three conditions are fulfilled. Which three conditions? First condition, between A and B at all the points, it should be continuous. At A, it should be right continuous. At B, it should be left continuous. How many of you got it? How many of you have understood it? Has everyone understood it totally, completely, absolutely, without getting confused? That's exactly what I was trying to talk about. Open and close. And if you have gotten this idea, shall we do a question here? Shall we do a question over here? Shall we try a good question here? So in this question, they're not asking you to figure out the continuity or discontinuity. Rather, they're asking you to figure out the type of discontinuity for this function. Okay, sir, let's try and do this. How do we do it? Can somebody help me? That, sir, how should you approach? How should we approach this question? How are we going to approach this question? Can somebody help me with that? Anyone? Anyone? How are we going to approach this question? Anyone in the comments? Good, Vijay, that's brilliant. Try and suggest me, what do you think? How am I going to assess its continuity or discontinuity and the type of discontinuity? Anyone and everyone? How do we do it? Sir, first of all, look at this part here. Ln of x square minus 4, which is inside a mod, that too in the denominator. This is how the function is defined. The only problem here could be is that, sir, you should avoid keeping denominator 0 because it is a rational expression. Something upon something, numerator upon denominator. So numerator is very well sorted. Numerator is clearly 1. But in the denominator, I'm seeing an expression in ln. And we know for a rational expression, denominator should not be 0. That's a very basic condition we think of, right? Okay, sir, you're saying denominator should not be 0. Yes, I'm saying that. So when I say that denominator should not be 0, that I'm saying that log of mod of x square minus 4 at base e, which is ln of mod of x square minus 4, should not be 0. So let's say, when do we find it 0? I'll do the opposite of it. I'll say the opposite of it. So it will be found to be 0 when e to the power 0 is this, which means mod of x square minus 4 is e to the power 0. NT log I have taken. I hope you know how to take the NT log. E to the power 0 will be equal to this. Remember the process of taking NT log? So e to the power 0 is 1. So mod when vanishes, mod when removed, gives you plus minus sign. So it will give me x square minus 4 as plus minus 1. Yes or no? Yes or no? Yes or no? So when 4 comes to the other side, x square we receive as 4 minus 1, 3. 4 plus 1, that's 5. So x I'll receive as under root over 3, but with a plus minus sign. Under root over 5 with a plus minus sign. These are the 4 values I have got it. Sir, everything looks cool, everything looks fine, everything is good, but why have you really done all of this? What are you trying to highlight? Subhash is saying by finding domain in range, domain specifically. Yes, I hope you got my point, everyone, that it will help us. We knew that denominator cannot be 0, which means this cannot happen, which means x should not be these 4 values. Sir, what have you really gotten or attained by doing this? Let me first of all show something really amazing to you, and then I'll come back to this part. I have this curve which I'm trying to draw, which I'm defining as, pay attention everyone, have patience, something really good will imagine or visualize here with this. I'm saying we are given y is equal to 1 upon log at base e, so ln actually. So where is ln of modulus of x square minus 4 and mod and this. Are you noticing this is exactly what I was trying to highlight? Sir, you said that we cannot take some points. Yes, I said. I talked about those points. Which points were you talking about, sir? I was talking about few points. Sir, few points means what? I was talking about technically 4 points. Plus root 3, minus root 3, plus root 5, minus root 5. But you let me know one thing, that here it is technically mod. Everyone paying attention, here it is technically mod. So mod means what? I hope I have taken the graph correctly. Let me just notice it. It is 1 upon ln of mod of x square minus 4. This is 1 upon, it is correct. And when you look at this graph, where is the graph? There is the graph. When you look at this graph, everybody paying attention about this function's continuity or discontinuity. Now look at these values. Look at these values. These values are clearly the points where I hope you're clearly noticing that here, these are the 2 points where the function is getting discontinuous. Which 2 points? Let me show or highlight these points. Look at this point over here. This point over here, there will be an asymptote. Imagine an asymptote over here. Let me just bring this screenshot so that I can make you visualize this more clearly. Hold on for a second, students. I'll bring a screenshot. So how do we take screenshot? Screenshot. I'm really sorry. I'm being in rush. So let us move slowly. So this is how you take the screenshot and then you save it. After saving it, you import it. So importing I'll do. So I'll explain it on the next page. So here we import it and then we import it from pictures, the capture, and then we enlarge it so that you all can see it, and then I'll show this to you. So I am saying one very interesting and direct phenomena which most of you must have noticed is that there will be a straight line going like this, parallel to the y-axis, of course, and there will be a straight line like this, parallel to the y-axis, of course, and these 2 points are going to be, this point is going to be plus root 3 and this point is going to be plus root 5. Similarly, there will be 2 straight lines here where it will be minus root 3 and it will be minus root 5. Now, what I'm trying to make you all understand is what all has happened here when I was not watching or looking at the comments. Yes, good to have you back, Mr. Kala Kaddu. Piyush, okay. Vijay is saying answers. Okay. Coming back, everyone. Coming back. Thank you so much, Mr. Kalakadu, for such a beautiful words of your appreciation. I am saying that look at this. At root 3, what is happening? Sir, root 3 if approached, you are clearly seeing it to be going in the towards plus infinity. But if root 3 is approached from here, it is clearly approaching towards minus infinity. So what kind of discontinuity it is? What kind of discontinuity it is? Sir, it is clearly a non-removable discontinuity because there is a jump of infinity. So I hope asymptote type discontinuity, or you may call it infinite jump or infinite type of discontinuity, which is of course a more specified version of non-removable. Everybody got it? Same is happening at root 5. The same would have happened at minus root 3 and minus root 5. So I hope you got it. First of all, these are the 4 points. And of course, these are the points where denominator becomes 0. And if denominator approaches 0, I hope you get it. Fx is technically something upon something. So if the denominator approaches 0, the whole fraction approaches infinity. But sir, it could approach plus infinity or minus infinity depending on what side you are coming from. So I hope you get it very clearly. Plus infinity and minus infinity. So of course, it is an infinite type jump, asymptote type, non-removable discontinuity. Everybody understood this question, this example. Are you making some sense out of this concept of discontinuity? Yes or no? Shall we do one more question to understand it more clearly, all the participants? Yes or no? Everyone with me? So the next question here says that here, fx is a function defined as this, where if x is 1, it is 1 by 2. If x is not 1, it is this. Okay. So we need to talk about the continuity of this function at 1. So we need to work out its continuity at 1. We need to put our view. We did it, Shubhash. I told you, algebraically also you can do it, but I wanted to show it to you first. This is the algebraic part, which you are concerned about. This is that algebraic part. You can clearly notice it, that if denominator approaches 0, the fraction approaches either plus infinity or minus infinity. So it will be infinite type, non-removable discontinuity. So you really don't have to look for this kind of a tool, but I have just demonstrated it so that you can understand it more simply. Got my point, Shubhash? Shall I move towards the next question? So let's talk about its continuity at 1. Sir, one thing we know that at 1, the value of the function is 1. Okay, that part is sorted. So if somebody asks me 1, f of 1, I'll say 1 by 2. But sir, what we need to figure out is, when this function approaches 1 from left hand side, what happens? When this function approaches 1 from right hand side, then what happens? So these two things we need to put our comments on. Shall we try? Everyone, are you all? Everyone. So if x approaches 1 from left hand side, now imagine this. If x approaches 1 from left hand side, imagine this. We are putting this limit on f of x. Then what happens? Sir, everything I'll write as it is. X square, of course, x is approaching 1 from left hand side. So I'll write it x approaching 1 from left hand side. X square minus 1 I'm keeping as it is. But here in the denominator, this x square stays like that. This minus 2 stays like that. Now imagine this. You are moving from any value which is on the left of 1, like 0 0.9, 0 0.8, 0 0.7, like those values. So if you put any value here, 0 0.9, 0 0.8, 0 0.7, just a value less than 1. So 0 0.9 minus 1, minus 0 0.1, 0 0.8 minus 1, minus 0 0.2. So all of these values inside this mod will be negative. Because if I move from the left of 1, x minus 1 will be negative. Yes or no? Which means this value x minus 1 inside this mod is negative. So when mod gets removed, it will be negative of this, which means negative of x minus 1, which is 1 minus x. I hope you got my point. I think Prajwalam is asking, sir, can I crack JEE only after watching these lectures and practicing the questions? It's tough to say, Prajwal, because I need to specifically know where do you really stand. But what I can really assure you of is that by watching these lectures, you can definitely get a lot for your JEE preparation, mains and advanced both. And very soon after we are done with the theory, we are going to bring, these are more concept oriented sessions where I'm trying to teach you the concepts. We'll do more practice oriented sessions as well, which are more focused towards practice of JEE mains and advanced questions, specific JEE mains and advanced questions. So we'll do a lot of sessions for you. You can keep watching and it will certainly help you. That's what my assurance to you is. So here, if I simplify the denominator, can I just take the denominator instead of solving the whole question? Yes, we can. So if I just take the denominator, it is x square. If I just simplify the denominator instead of the whole question. So the denominator looks like what? X square minus plus 2x minus 2 minus 1. That's minus 1. Yes or no? So if I factorize it, I need the product to be as minus 1, sum as plus 2. Will it really work? Can I get it solved? I think there is a problem. I'll simply cannot, because if I substitute x as 1, 1 plus 2, that's 3 minus 1. Okay, so it is sorted. It is x square plus 2x minus 1. So this limit looks like what? Limit x approaching 1 from left hand side, where the numerator is x square minus 1 and denominator is x square plus 2x, and then you have minus 2 minus 1. I'm really sorry. Did I make any mistake? Yes, I did. It is minus 2 minus 1. That's minus 3 actually. So I made a calculation error. I'm really sorry. So now when I factorize it, what do I get? Sir, we get limit x approaching 1 from left hand side. Numerator is x plus 1 into x minus 1. I have used a plus b, a minus b. But what do we do in the denominator? I think plus 3 minus 1. Can I write x square plus 2x minus 3 as x square plus 3x minus x minus 3. So one of the factors will be x plus 3 and other factor will be x. I'll take common from here, minus 1 I'll take common from here. So 1 and 1 are cancelled. So ultimately it gives you what? It gives you limit x approaches 1 from left hand side in the numerator x plus 1, denominator x plus 1, x plus 3. So x plus 1 by x plus 3. So LHL comes out as what? 1 and 1, that's 2. 1 plus 3. If I'm substituting this value 1, so 1 plus 3 is 4 and 2 by 4 is 1 by 2. So sir, luckily LHL is also 1 by 2. LHL is also 1 by 2. So we have worked out something really good, something really nice. Okay, fine. Now when I move ahead with RHL, so what do we do with RHL? Okay, sir, let's try and find RHL here. So with RHL, I'll be doing x approaching 1, but from right hand side on the same expression, which is x square minus 1 in the numerator, but denominator has x square minus 2. Now imagine any value greater than 1 if you push, any value greater than 1 if you put, let's say 1.1, 1.1 minus 1, 1.2 minus 1, 1.3 minus 1, it will be positive. So there is a positive value inside the magnitude, which means what? Magnitude, I mean modulus sign simply gets removed. So I'll say minus 2 times x minus 1. Mod will simply get removed, yes or no? Because it is positive inside the magnitude sign. When x is approaching 1 from right hand side, x minus 1 is positive, which means mod will simply vanish. And I'll say minus 2 times x minus 1 minus 1. Everybody got it, whatever I've done. With this, if I simplify it, the numerator looks sorted. Limit x approaching 1 from right hand side. Numerator is clearly x square minus 1. What about the denominator? So it is x square minus 2x, correct me if I'm wrong, plus 2 minus 1. That I think is plus 1. I hope you're getting it correctly, yes or no? Plus 2 minus 1. So it is a square plus b square minus 2ab. So I hope you are clearly noticing x square minus 1 can be written as limit x approaching 1 from right hand side. Numerator is a square minus b square, a plus b, a minus 1, a minus b. Denominator is x square plus 1 square minus 2 into x into 1, which is x minus 1 whole square. Yes or no? Yes or no? So it will be x minus 1 whole square. Everybody got it without any confusion? With this, what do we see? Sir, with this, what we see is x minus 1 getting cancelled. So we see limit x approaching 1 plus numerator is x plus 1, denominator is x minus 1. And are you all noticing and seeing the problem? What's the problem here? The problem is that when x approaches 1, numerator is 2, denominator is 0. So actually, it approaches infinity, and that too plus infinity. Yes or no? So when we were talking about RHL is approaching infinity. So what kind of discontinuity it is? It is first of all discontinuous. Everyone noticing it? Yes or no? What kind of discontinuity? Whatever is the curve, at 1, what must be happening? Sir, around 1, LHL and the value of the function are 1 by 2. So whatever is the curve, it would be approaching 1 by 2 like this. I'm just giving you a rough sketch. I'm not sure about this. But at 1, I hope you are understanding. RHL is going towards infinity. So at around 1, it would be going like this. So it is clearly an infinite type, non-removable discontinuity. Everybody understanding it? Yes, left continuous only. That's a very good observation, Vijay. Keep it up. इसमें वो pop-up आ रहा है एक हटाना. Did you all get it? All the participants? Yes, it is simply left continuous because LHL and the value of the function are same, whereas RHL is simply infinity. Shall I move ahead from here? Did you all get this clarity about continuity, or are you still feeling confused? Everybody, give me a quick response. Let me have some water and then we'll resume. By the time you read this, Prajalam is saying, Prajalam, coincidentally, if you visit our video section and short section, we have covered your concerns only. Recently, we have released a video where I have covered this point only, that with these remaining 6 months, how can you prepare for JEE? Just watch it. Trust me, it will certainly help you. After this session, just go through it. And one video on books as well will be released very soon. So you'll get a total crystal clear clarity specifically for you. Trust me. With Ved is also here. Good to have you, Ved. When do we know what we can use L'Hopital? I am God. You can use L'Hopital whenever you're having a 0 by 0 or infinity by infinity form, but not always you will be finding it very efficient. Because in JEE, they'll ensure that they'll make you fall into a trap of using L'Hopital, and when you keep using it, it will make you fall in a lengthy loop or a huge loop or sometimes infinite loop where you won't be able to get the answer very easily. So not always L'Hopital is very handy or useful. You may find it very easy. You may call it a short trick, but it is actually not a short trick. Not always. Yes, Vijay. So understand the graph here. I'm trying to again, the best thing is I'm trying to say, Vijay, in the previous case, in the previous question, let's say this is the y-axis for a while. This is the x-axis for a while. And there is a point 1 over here. So at 1, it is 1 by 2. That's how the function is defined. And it is left continuous. For example, if the graph is going like this, it is approaching 1 by 2 from the left-hand side. But at 1 by 2, Vijay, my friend, what happened was that at x is equals to 1, what happened was that this curve was approaching plus infinity from the RHL. So are you not seeing that this is a discontinuity? And why infinite type, Vijay? Because there is an infinite difference here. This jump between this point, whatever it is, I don't know, of course, infinity plus infinity, and this point is 1 by 2. So there is a difference. I hope you see infinity minus 1 by 2 is still infinity. I hope you're getting it. So there is a jump of infinity. So this is an infinite type discontinuity. Have I answered your query, Vijay? Did you all get my answer? Or are you still feeling confused? There's a jump of infinity, and if there is a jump of infinity, we call it non-removable infinite type discontinuity. Shall I move ahead? Everyone with me so far? Yes, I remember everyone. Thank you so much for being here. Let's study now. So there we are given, let's say, fx and gx as two functions. They both are, let's say, continuous in a certain interval. And then without any hesitation, let's say if I'm given two functions, for example, one of them is fx, other one is, let's say, gx. So if fx is continuous, gx is continuous, then their sum, their difference, their product, and their division all will be continuous, which means fx plus gx will be continuous, fx minus gx will be continuous, fx into gx will be continuous, fx by gx will be continuous. You just need to ensure that you cannot take those values of x for which gx is 0. So those values of x, how will I write it? The values of x should be not taken except for those values. I'll write it alphabetically. I mean, in literally, except the values of x for which gx is 0. Of course, that should be considered, sir, because denominator is technically a problem. We cannot keep it 0. Okay, great. Perfect, brilliant. Good to have you all. Shubhash, Ariman, everyone. Are you all comfortably getting it? So this property, I hope, makes complete sense. This is a theorem which I'll be using. For example, let's say, how will I use it? Let's say I'm given a function sin x. I'm given a function e to the power x. So, sir, I know that sin x is continuous. Continuous everywhere. Continuous for all x which are real. Sir, e to the power x is also continuous for all x which are real, which means their sum I can without any hesitation say will be continuous for all x which are real. Not just that, I will say sin x minus e to the power x will also be continuous. I'll say sin x into e to the power x will also be continuous. I'll say sin x upon e to the power x will also be continuous for all x which are real, except for those values of x where e to the power x is 0. And fortunately, e to the power x is never 0. E to the power x is always positive. So this is also continuous for all x which are real. Everybody understood this very simple, direct, straightforward theorem which we'll be using while working out the continuity. But whatever I've said so far, I did not say opposite of it. You sometimes assume the opposite of it. What do I mean by that? Let's say fx is continuous, gx is discontinuous at a certain point, then their sum or difference will definitely be discontinuous. You can unhesitatingly say this. But I'm not saying this is true for product or division. What did I just say? I am saying, let's say there is a function x square plus 3. Sir, this is continuous everywhere. Yes or no? Let's say there is one more function. Signum of x. One of our students in our batches calls it Signum. So Signum of x. But sir, Signum of x we know is discontinuous at x is equal to 0. I hope you remember the graph of Signum. This is how it goes like. Remember that? So it is clearly discontinuous at 1. So sir, what can you say about their sum or difference? So let's say if I'm doing their sum, x square plus 3 plus Signum of x or even minus of Signum of x. So one is continuous at 0. This is discontinuous at 0. So their sum or difference will definitely be discontinuous at x is equal to 0. That you can surely, without any doubt, say. You can always say this. You can always claim this. Everybody got my point? Everybody understood my point? But what I did not say is about their product or division. Why? Absolutely, Vijay. Absolutely. I was expecting that somebody would say it. Beautiful. All I'm saying is one more property which we are going to discuss now is that if I'm given two functions, fx and gx, where fx is continuous, gx is discontinuous, then their product could be or could not be continuous. Which means, let's say here I'm given two functions. One is continuous, other one is discontinuous. Let's say which one shall I take? Anyone you can take. Let's say there is a function. What example have we taken here? Signum and x cube only. Okay, perfect. So we have x cube as one of the functions and we have signum of x as the function. So this time I'm multiplying these two functions. Multiplication means what? This x cube is continuous everywhere. Yes or no? This signum of x is discontinuous at x is equal to 0. So sir, what about their product? I cannot say. I mean, I can only after figuring it out manually. We'll have to do it. By looking at the product only, I cannot say that product of continuous and discontinuous will be necessarily discontinuous. No. It can be continuous, it can be discontinuous. That will have to work out. So we need to work it out. Did you all get it or shall I repeat it? Everyone, give me a quick response. Has everyone gotten it? I repeat, product of a continuous and discontinuous function could be continuous or discontinuous, I just don't know it yet. I can by only figuring it out. I'll have to work it out by myself. I'll have to work it out by myself. Everyone understood it. But along with this, there comes a very important corollary to it, very important fact to it. If you have the function, which is, let's say, x cube or x, let's say fx is equals to x. Let's say this is simply fx. Let's not introduce x here. Let's say this is fx. So there is a function fx which is continuous. Okay, so they have taken a deliberate example. So let me just keep it like this. So there is a function which is continuous for all x, and there is one more function gx which is discontinuous at all the integral values because it is GIF of x. Good, Subhash. Brilliant if you're getting it. Perfect. So I am saying that in this case, f of x, there is some typing error here, I think. F of x is discontinuous. No. I think there is some typing error here. Let me explain this. Forget this whole thing. I am saying that there is a function, let's say, x, and there is some function, let's say, GIF of x. So what are you trying to say here? I am trying to say x as a function is continuous for all x which are real. This is also continuous, but it is discontinuous at all the integral values, which means GIF of x is discontinuous at all those values of x for all those values of x which are integers. I mean 1, 2, 3, minus 1, minus 2, minus 3, add these values, it is discontinuous. So sir, you are saying the product of a continuous and discontinuous could be anything. Yes, it could be anything. It could be continuous, it could be discontinuous. But here you have an advantage, you have a liberty. Sir, what liberty? The function which is continuous, let's say I want to check its continuity at 2 points. I want to check its continuity at 2 points. Let's say I want to check its continuity at x is equal to 1, right? So at x is equals to 1, this is clearly discontinuous. At x is equals to 1, this is continuous. But at x is equals to 1, this is not 0. Sir, what are you saying? Listen to me very carefully. The one which is continuous at 1 is not 0 at 1. It is 1 at 1. So the function which is continuous at 1 is not 0 at 1. And that's why non-zero into discontinuity will be discontinuity at x is equal to 1. What did I just say? I am saying, let's say I'm checking its continuity at x is equal to 0 for a while. So I repeat, I am saying that at x is equals to 0, if you want to check its continuity, here, this is clearly discontinuous at 0. So this is discontinuous, but this is continuous at 0. Listen to me very carefully. The one which is continuous at 0 is 0 at 0. What did I just say? I said this x is continuous at 0. But luckily, it is 0 as well. So what I'm saying is, the one which is continuous and 0, so 0 of continuity into discontinuity dissolves the discontinuity and makes it continuous, which means this will be continuous at x is equal to 0. Let me see whether we have this feature available or not of this function GIF of x. If it is available, I would really love to show this to you concept here. So let me use this. Y is equal to x into function GIF, greatest integer. What do they call it? Do we have GIF? Geometry, custom. Floor function of x. Now, this is exactly I'm trying to show to you. Everyone, please pay attention. Look at the beautiful thing here. At every integral value, look at this. At every integral value, you will see the graph breaks. See, what value is it? This is the value -1. It broke. LHL and RHL, not same. Look at minus 2. Look at minus 2. Minus 2, the graph clearly breaks. I hope you're seeing. But 0 is clearly a point where LHL and RHL both are same. Everybody understanding my point? Everybody understanding my point? Sir, what is your point? My point is very simple. That continuous into discontinuous, we don't know, but it will be continuous if this continuous one becomes 0 at that point. Have I answered this statement? Have I made you understand this statement clearly? Is everyone comfortable with whatever I've said so far? This theorem, does it make complete sense? Are you all able to process it? Everyone. Now the next case. Let's say if I'm given two functions, fx and gx, and both of them are discontinuous. Fx is discontinuous, gx is discontinuous. Then, sir, what about their sum, difference, product, or division? I repeat, if there are two functions, fx and gx, and both of them are discontinuous, at a certain value of x, which is let's say a, both of them are discontinuous. Then their sum, difference, product, or division can be or cannot be continuous. So what do you mean by that? Yes. I am saying a very simple fact which you all need to process is that if let's say there are two functions fx and gx, if both are continuous, let me just draw a table so that it will make complete sense. I'm giving you a final table which will help you in understanding it to a great extent. I'm going to talk about a few things now. So if I just draw a few things, here I'll talk about the functions. Here also I'll talk about the algebraic operations, and then I'll be writing few things. So I am saying that what I know is that there is a function f and there is a function g. There is a function f and there is a function g. Now, let's say I know that fx and gx both are continuous. One case. Everyone listening and understanding? Then we know one thing, sir, that if you want to talk about fx plus gx, fx minus gx, fx into gx, or fx divides gx, what we know clearly is that, sir, whatever you do, sum, difference, product, or division of two continuous functions, it is always continuous. Do you remember that? Do you all remember that? Yes or no? Everybody. Give me a quick response. Let me just copy all this so that we can talk about different cases. Hold on for a while, students, so that I can create this table and make it understandable. Few cases I'll be taking and explaining. So, sir, if both of them are continuous, then what happens is, both of them are continuous, their sum is continuous, their difference is continuous, their product is continuous, their division is also continuous, denominator should not be 0. That's a condition which we impose. Now, second case. Sir, if fx is continuous, gx is not. So if one is continuous, other one is discontinuous, their sum will be discontinuous, their difference will be discontinuous, their product I don't know, their division I don't know, their product and division may be, may not be. So I just don't know. So this don't know sign I'm representing by this. But there is a very important conclusion that here fx into gx could be continuous if fx is 0 at that point. The one which is continuous, if it becomes 0 at that point, it will become continuous. I hope you have seen it with x into gif of x. Same thing I'd say with this scenario as well. Let's say if fx is discontinuous, gx is continuous, sum and difference will be discontinuous, product and division I just cannot say. But again, if gx becomes 0 at a point where f of x is discontinuous, their product will be continuous. Everybody processing this idea? Now the last thing. This is the most crucial part. fx and gx both are discontinuous. Then their sum, difference, product, division can be continuous, cannot be continuous. I just don't know. Yes. Are you sure, sir? Yes. Can you give us some examples? Yes. First example. let's say if I take GIF of x in fraction part of x. First example, if I take fx as GIF of x and gx as fraction part of x. Sir, GIF of x is discontinuous at all the integral values of x, yes or no? Fraction part of x is also discontinuous at all the integral values of x, which means their sum, I don't know, because both of them are discontinuous. So their sum I know, for any number, its GIF and its fraction part sum is always 1. And 1, unfortunately, is a constant function. This was discontinuous at all the integral values of x. This was discontinuous at all the integral values of x. But 1 is a constant function. So if fx is GIF of x, fraction part of x is g of x, but their sum is turning out to be 1, which is a constant function, and a constant function is continuous everywhere. So both of them were discontinuous, but their sum became continuous. So sir, are you saying it will always be continuous? No, I did not say this. I said, I don't know. This is a contrary example to that. Have you all understood it? Have you all gotten this? Shall we take or talk about some more examples? Look at this scenario. Again, a very beautiful example. Pay attention, everyone. Here we are told that fx is minus 1 if x is negative, and if x is positive is 1. Gx is 1 if x is non-positive, minus 1 if x is positive. What about their product? Fx into gx. If you look at their product fx into gx, I hope you are noticing minus 1 into 1 will be minus 1. So for all the values of x which are negative or which are non-positive, it is minus 1. And sir, for value of x which are positive, it is 1 into minus 1. For values of x which are positive, it is 1 into minus 1. So it is again minus 1. So sir, whatever value x takes, negative, positive or 0, it is always minus 1. I hope you're getting it. I repeat, this function is discontinuous at x is equal to 0. This function is also discontinuous at x is equal to 0. Are you noticing it? Minus 1 and 1. There is a break, a jump of 2 units. So both of them are discontinuous at x is equals to 0, but still their product turn out as continuous at 0. So I hope you are clearly realizing. Tushar, good to have you. Thank you so much for your appreciation. I say that if there are two discontinuous functions, their sum or difference or their product or their division could be continuous, could be discontinuous. I just don't know. Which means I'll have to figure it out. I'll have to work it out. Everyone understood it. And if you have understood it, let's talk about all of that through this one single example. Shall we, everyone? Shall we try this question? Can you all see this question right there on the screen? Everyone, all set already? So what does the question say? It says fx is defined as this and gx is defined as this. Then we need to talk about fx plus gx. Before I talk about fx plus gx, can I be a little more specific with fx and gx? Yes, I can. Let's try to be that. So fx, when I redefine, it can be redefined as this modulus I want to remove. So what I'll say here is x plus 1 mod, critical point will be minus 1. Aryaman is saying, sir, when we take integer values only, then GIF of x and fraction part of x are continuous. I did not get your statement. Let me reread it. Aryaman is saying, when we take integral values only, then GIF of x and fraction part of x are continuous. No, that's where it breaks, Aryaman. Don't you know it? Shall I show it to you directly here so that I don't have to draw it? Look at the floor function, Aryaman. Floor function is clearly this. I hope you can see this. We call it step function as well. So it clearly breaks. At 1, I hope you're noticing at this point, at 1, if you zoom it in, at 1 it is not 1. Sorry, at 1 it is not 0. At 1 actually it is. At 1 it is actually 1. So the graph breaks. So Rmn, I'm saying that at all the integral values of x, GIF and fraction part breaks. Which means GIF and fraction part both are, no, they are not defined. They are defined, but they are breaking, the graph breaks. But their sum, when we talk about their sum, which means, let me do it here. Their sum, floor of x plus fraction part. How do they define it here? Let me see. Do we see define round signum ceiling GCD mod ceiling floor fraction part they haven't taken. I don't know whether round is called fraction or not, but let me try and do it. I don't know, I'm just experimenting it here. So I think round is something different. Round is something different. Forget it. So I'll do it here. We know GIF of x is discontinuous for all the values of x which are integer. Fraction part of x is discontinuous for all the values of x which are integer, which should not make you think that, sir, there are some two functions which are discontinuous at some values, their sum will be discontinuous or continuous. It can be either. How do we figure out? We figure it out. Manually we do it. So luckily here in this case I know is that the sum is clearly plus 1. Sorry. What did I say? I am thinking, let me just go back. I think we made a mistake. Let me just recheck this part. There I think I made a mistake. What did I say? Did I say 1? I think I made a mistake. I'm really sorry. I am really sorry. I am really sorry. I am really, really sorry. I'm really sorry. I don't know in which world I was. I said it to be 1. It is x. I'm really sorry, first of all. I'm really sorry, first of all. I am saying that GIF of x and fraction part of x is x, and x is an identity function. An identity function is constant. I don't know why did I say it 1. Maybe some, I was lost somewhere else. So here I come back to explain this again. There is a function, let's say fx, which is GIF of x. There is a function gx, which is fraction part of x. They both are discontinuous for all the integral values of x. Let's say I define one more function h of x, which is fx plus g of x. So we know GIF and fraction part of x sum is x. So I am saying if h of x is x, which is technically sum of two discontinuous functions, but if I draw the graph of hx, it is turning out to be an identity function, which is continuous everywhere. So two discontinuous functions sum can be continuous, cannot be continuous. We need to work it out. Oh yes. So if I do it, I'll finally get this. Very beautiful observation, Ariman. Thank you so much. So if I simply do it on that panel, GIF of this is fraction part of any function is this. So if I add it, they are cancelled. I'm left with x. So I hope you get it now. Were you asking the same thing? Or were you asking for something else, Ariman? Have I answered your query? Shall I get back to the question? Here I'm trying to redefine fx and gx both. Great. Moving ahead. Thank you so much. By your doubt, I could correct a mistake which I made. Good. And nobody highlighted when I wrote x plus, GIF of x plus fraction part of x is 1. Nobody highlighted that I'm making a mistake. Okay, so here x when becomes -1, that will be my critical point. So I'll say that when x is less than -1, that's a point. When x is greater than -1 and less than 0, that's a point. And when x is greater than 0, that's a point. So when x is less than -1. Remember the graph is identity function. Have I not shown you this here? This is the graph. GIF of x plus fraction part of x is x. So do you not know how to draw the graph? Y is equals to x. Identity function. This is the graph. If you add GIF of x with fraction part of x, so this and this are cancelled. What are you left with this? I am left with this identity function y is equals to x. I hope you're aware of it, aren't you? So continuing further, when x is less than -1, take any value which is less than -1, -2. -2 plus 1 is negative. If it is negative, it opens with a negative sign. So it will be -x minus 1. If I take any value between -1 and 0, let's say -0.5. -0.5 plus 1 is positive. So if it is positive, it will open the way it is. So if I take any positive value, it will be simply x. So this is how it is defined. Everybody got it? Similarly, sir, can we see better simplification of gx as well? Yes, we should. So if gx needs to be simplified, I'll say when x is less than 1, I'll split it into two parts where I'll say when x is less than 0. When x is less than 0. So when x is less than 0, yes. When x is less than 0, mod x will be -x. Opens as -x. So this will be 1 minus x. Everybody getting it without getting confused? Yes or no? Now, next thing, when x is from 0 to 1, when x is from 0 to 1. So the moment x is from 0 to 1, I hope you are clearly realizing x is non-negative. So if x is non-negative, mod x opens as x, so it will be x plus 1. Right? Okay, good, great. Now when I talk about x taking any value greater than 1, when I talk about x taking any value greater than 1. So sir, here there is a critical point 2. So you split it into two zones where you say x is greater than 1 till 2, and then you say x is greater than equal to 2. Two zones I'm dividing because x minus 2 becomes 0 at 2. So I'll divide it into two parts. Everyone understanding it? So when x is between 1 and 2, when x is between 1 and 2, it will be negative. For example, 1.5 you put. 1.5 minus 2 is clearly negative. So if this expression inside the mod is negative, it will open with the negative sign. So negative of negative is positive, so I'll be left with x minus 2. I'll try to bind it up by 11 o'clock. Okay with Ved? And if x is greater than 2, which means this x is greater than 2, 3 minus 2, positive. So if it is positive, it opens with the same sign, no change, but there is already a minus outside, so it will become 2 minus x. Everybody got it? Now, sir, what are we going to do? I am now going to add both of them. I am now going to add both of them. So if I now wish to add both of them, so I am doing fx plus gx. Shall I do it there? So I'll be doing fx plus gx. Shall I write fx plus gx, everyone? Are you all ready? So I'll be writing fx plus gx. Here, if I do it, it is okay, I believe so. So when x is less than 0, I hope you're getting it. When x is less than 0, this definition can be picked up because, okay, so I need to break it into two parts because x is either less than minus 1 or x is between minus 1 and 0. So I'll break it into two parts where I'll say that when x is less than 0, 1 minus x. So 1 minus x when x is less than minus 1 as well, and 1 minus x when x is from minus 1 to 0. Everyone getting it? Yes or no? I have just written it twice. Sir, why have you really done it? Have patience, you'll start understanding it. First of all, this is not fx plus gx, this is still gx only. This is still gx only. But sir, why are we really doing it? We are doing it because I want to add fx to it. I want to add fx to it. Everyone paying attention here without getting confused. Let me just look at this part. Minus 1 to 0. That's sorted. X positive. That's sorted. I think everything looks sorted. Now I'll write fx plus gx. So I'll be writing fx plus gx now. So pay attention, everyone. This is our gx. Now I'll add fx to it. So when fx, x is less than minus 1, this is fx. When x is less than minus 1, this is gx. So minus x minus 1, if I add here, this will be fx plus gx for all x less than minus 1. Now, when x is from minus 1 to 0, this is f of x. When x is from minus 1 to 0, this is g of x. So f of x, when added to g of x for all these values, this is f of x plus gx. Now, when x is positive, everyone getting it? It is x, yes or no? When x is positive, it is x. So when x is positive, this is gx. So I'll add x fx plus gx. I'll add x fx plus gx. I'll add x fx plus gx. Because for all the positive values of x, fx is x. But for all the positive values of x, gx is taking these three different values. So I'll simply add x. Unfortunately, no, Mr. Keyboard. I hope everybody got it. So now what I'll do is I'll simply remove this part, and I have finally been able to get fx plus gx. Everybody got it without any confusion. Sir, now shall we simplify it? Yes, we should, so that we can finally talk about its continuity. Yes or no? So sir, if you want to talk about its continuity, here 1 and 1 are cancelled, it's minus 2x. So this thing simplifies as minus 2x. Here x and x are cancelled, so it's technically plus 2. So it is plus 2 for these values. This will be 2x plus 1. This will be 2x plus 1. Here it will be 2x minus 2. It will be 2x minus 2, and this will be x and x cancelled. It is again plus 2. Any confusion so far on whatever I've done? Namaste, Mr. Uday Sai. What do we do next? I'll draw the graph. And with this, I'll talk about continuity. So do we really need to have to draw the graph? No. I think minus 2x is continuous, straight line. 2 constant, continuous. 2x plus 1 straight line. 2x minus 2 straight line. 2 constant. Everything is continuous in its domain. So where do I need to check it? I need to check it where the function is changing its definition. When you're changing the gear, there you need to focus. Yes, with the piecewise, you need to be very careful. Of course, you will understand it. I'll say, what about LHL and RHL at minus 1, LHL and RHL at 0, LHL and RHL at 1, LHL and RHL at 2. So what if I do it here only? Will you be able to understand it? If I do it on this page only? So let me start writing all these values. LHL and RHL at minus 1. So let me call it for a while hx, the sum. So I am asking you LHL. So LHL at minus 1 will be this minus 1 into minus 2, that's 2. But what about RHL? RHL at minus 1 will be 2. So are LHL and RHL and the values of the function is same? Yes. So if that is same, I'll say function is continuous at minus 1. Yes or no? Now, let's talk about LHL and RHL at 0. So LHL at 0 is 2. Sir, what about RHL at 0? RHL at 0 is 0 into 2 plus 1. 0 into 2 plus 1 is 1. So, sir, LHL and RHL are not equal. If LHL and RHL are not equal, the function is clearly discontinuous at 0. So, at 0, it breaks. So, first point I have gotten. Points of discontinuity, if I write, first point will be 0. Comfortably getting it, everyone? Now, the next thing. If I find LHL and RHL at 1. So, at 1, 2 into 1, 2. 2 plus 1 is 3. RHL at 1 will be 2 into 1, 2. 2 minus 2 is 0. So, sir, LHL and RHL are not equal at 1. And if they are not equal at 1, I got another point of discontinuity, which is 1. Yes or no? Now, the next thing. This is, of course, for mains and advanced both. We are developing the core concepts of limits, continuity, and differentiability. Limits, one shot we have done already. This is for continuity and differentiability. Here comes the next part. I'll take LHL and RHL at 2. So if I talk about LHL at 2, 2 into 2, 4. 4 minus 2 is 2. RHL at 2, 2 at 2 is 2, because RHL at 2 is 2. I hope this is the part you are already comfortable with, because we have done limits in the last session. So I think I should have changed the color here, because I'm saying continuity means green for a while. Discontinuity means red for a while. So it is continuous at 2. So only 2 points of discontinuity I'm getting, which are 0 and 1. Everybody got it. Everybody understood it. Yes or no? All the participants. Everyone comfortable with this part? Any queries or concerns if you have, please ask. So when we were asked about discontinuity of fx plus gx, I'll have to do it manually. At 0 continuous. Why? At 0 it is not continuous. At 0, RHL is 1 and LHL is 2. So Vijay, at 0 and 1 it is discontinuous. What makes you think at 0 it will be continuous? I hope you are seeing this is the definition here. 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 And this is the definition here. So at 0, how do you check it? At 0, LHL is 2. At 0, RHL is 1. I'm explaining it already again, Vijay. Focus. I am saying that at 0, LHL is 2. Getting it? But at 0, RHL is 0 into 2, 0 plus 1. So that's 1. So LHL and RHL are not same. Yes, so 0 is the point where LHL and the value of the function is same, but RHL is not same. So how can it be continuous? Good to have you, Rishit. Uday, everyone. Good to have you. But are you getting my point? Vijay, have I answered your query? Did you get it now? Okay, so we'll talk about continuity of few more specific functions after the break. So I'll be having my dinner. You also take a break, hydrate yourself, stretch a little, move around, walk a little, and then we'll meet after 15 to 20 minutes. Is that okay? So there is a break of around 15 to 20 minutes and then we'll resume. So there is a break. I'll have my dinner. You also take something. Take a break first of all, and then we'll resume. So don't stay seated for a long period. We'll move, resume in a while. So everyone, can you all hear me? Can you all see me? Everyone, I hope I'm clearly visible and audible. So here we are. The break is over and we'll be resuming our session again. Are you all there? All the participants? So Rishit is saying, when is the next class? In the next week? Every week we have classes for physics, chemistry, and maths. So in every week you have 3 classes. So 1 week, 1 subject. Okay. So if maths is getting conducted today, in next week also you'll have another class of mathematics. Any other queries or concerns? So I'm clearly visible and audible. Good to have you, Craft AI Co. Everyone, come back and we'll resume with our discussion. Can you all see me? I hope if the laptop is open somewhere, desktop is open somewhere, and if my voice could still reach you, come back, sit on the table, desk, wherever you are, and start rewatching. Duration, as I've told you with Vijay, with Ved, the class will go around till 10, 10:30. Between 10 and 11, I'll try to finish it, but I'm not sure. So by 11, yes, I'll try to finish it. Shall we resume, everyone? Now, GIF or fraction part. What is the problem? As we have discussed, even in the chapter limits as well, do you remember that? Here also, I'll say the same thing. We are back. Okay, good to have you all, everyone. We are resuming with our discussion. So pay attention, everyone. All I'm saying is that if I draw the graph of GIF, so how do we draw the graph of GIF? This is how we draw the graph of GIF function. Do you remember that? So I hope you do notice that there is one simple thing that, sir, the graph breaks. This is clearly nothing but what? This is the graph of GIF of x. So whenever I approach any integral value, do you notice it? Sir, when 0 is approached from left or right, the LHL and RHL are different, because when 0 is approached from left, the value is -1. But when 0 is approached from right, the value is 0. Getting my point, everyone? So my point is pretty simple, that here, at every integral value, LHL and RHL are different. At every integral value of x, the graph breaks, the function breaks. And that means it is discontinuous. The same you would observe and notice for fraction part as well. Sir, what do you mean by that? Here, let's say if I'm told fraction part of x, so how do you see the graph of fraction part of x? Sir, graph of fraction part of x is also pretty simple. I hope you do remember that. Okay, great, Ariman. Fraction part of x means what, sir? Fraction part of x goes like this. Remember that, students? Fraction part of x goes like this: -1, 0, 1, 2. And again, when you notice it, let's say any integral value I'm approaching, let's say 1 I'm approaching. So if I'm approaching 1 from left hand side, you are approaching 1. But if you're approaching 1 from right hand side, you are approaching 0. So again, LHL and RHL are not same. If LHL and RHL are not same, the function breaks, the graph breaks. And if the graph breaks, again, it is discontinuous. So I am saying two direct and straightforward things to you, that whenever we talk about fraction part, GIF, or even Signum, look at Signum. What happens with Signum? Sir, I'm really sorry. It is 1 for all the positive values of x. It is -1 for all the negative values of x. Thank you, Rajesh. What's strong to नहीं? And it is 0 at 0. It is 0 at 0. Again, this is what? This is Signum of x. So if I am drawing Signum of x, what is clearly happening over here is, I hope everybody is noticing, when 0 is approached from left hand side, you approach -1. When 0 is approached from right hand side, you approach +1. And at the value of the function at 0 is 0. So again, it breaks. So Signum of anything gets discontinuous when that anything approaches 0. At 0, it is discontinuous. I hope you're comfortably getting it. No confusion regarding whatever we have done so far. For example, let me take some examples. Let's say if I'm taking Signum of ln of x. Signum of ln of x, let's say I want to draw. So how do we draw it? I'll say, to draw Signum of ln of x, there are 3 cases. Sir, it will be 1, 0, or -1. Signum of ln of x will be 1, 0 or minus 1 whenever ln of x is positive, whenever ln of x is 0, and whenever ln of x is negative. Now, I am saying that ln of x is positive means what? Sir, signum of ln of x will be 1 if ln of x is positive. Now, I hope you know how to take antilog. Antilog means here, if ln of x is positive, which means x is greater than 1. Sir, we didn't get it. Can you re-explain? Okay. I am saying log x at base e is greater than 0. So e to the power 0 will be less than x, which means x will be greater than e to the power 0, which is clearly 1. That's what I said. If you didn't get it this way, although you should be able to, but there is one more approach, the graphical approach. This is how you see the graph of ln of x. So this is a point 1, comma 0. So after 1, I am clearly noticing the graph is above the x-axis. That's exactly what I'm saying, that after 1, the graph is above the x-axis, which means ln of x is positive for all the values of x which are greater than 1. Absolutely, Vijay. Beautiful. Now, similarly, ln of x is 0. Where? So ln of x is 0 when x is 1. I hope I need not tell you this simple thing, that when x is 1, ln of x is 0. Yes or no? Everybody, give me a quick response. And sir, what about this part? When do you see ln of x to be negative? Sir, ln of x is negative. That means below the x-axis on the negative side of y-axis between 0 and 1. If x is between 0 and 1. Remember that? Although you can solve it, e to the power 0 should be greater than x, which means 1 should be greater than x. So x should be less than 1, which means x will be between 0 and 1, because x is passed as an argument to ln. So x is supposed to be greater than 0. So what I'm getting is that this will be minus 1. So these are the 3 values I have gotten. I hope you are clearly noticing that at x is equals to 1, signum of ln of x is discontinuous. Everybody got it? Absolutely, Ariman. That's a valid point. So I hope everybody got it. Still, it is confusing you. I'll show it to you graphically. What do I mean by showing it to you graphically? Here, let's say if I were to draw the graph of signum of ln of x. So what will happen in that case? Here, 3 zones, greater than 0, equal to 1, and greater than 1. So 0, 1, and greater than 1. So between 0 and 1, it is minus 1. Between 0 and 1, it is minus 1. So this is the graph. Between 0 and 1, it is minus 1. So this is the graph. Of course, at 0, it is not defined. So this is the graph. At 1, it is 0. So this is the point. And after 1, that means between 1 and infinity, it is 1. So this is how the graph of signum of ln of x look like. And I hope it is clearly visible that at 1, the graph breaks, because LHL at 1 is minus 1. It is minus 1 actually. At 1, the RHL is plus 1. And at 1, the value is 0. Everybody got it? Or are you still feeling confused? Everybody. I hope you're clearly noticing one very simple, straightforward, direct fact. What is that? That is, signum of anything is discontinuous whenever that anything is 0. I hope you got it. Fraction part of anything is discontinuous whenever the expression inside the fraction part is an integer. GIF of anything is discontinuous whenever the expression inside that GIF is an integer. Getting my point? Yes or no? Yes or no? Yes or no, everyone? Shall I move ahead from here in that case? Let me explain some questions so that you can get it more clearly. Let me take any of these examples to make it more understandable. Shall I begin with the first one? Rest I'll give you as homework. Sir, can we have this PDF? Yes. How? To have this PDF, all you need to do is the free enrollment link for this course. Yes, you can enroll for this course at absolutely no cost. How? The link is given in the description of this video or even as pinned comment as well. So when you open it up, you will see the free course where we are providing these one-shots of physics, chemistry, and maths of all the chapters of class 12. And these notes and 24/7 doubt support system is also provided to you. Can you believe this? At no cost. Yes, you heard me right. So this entire PDF of this entire chapter, Continuity and Differentiability, will be yours for your revision at free. After the session on our application, if you are a freely enrolled student. Shall I get back? Everyone. F of x is GIF of x by 3. As I have told you, whenever x is an integer, GIF of x is a discontinuous function. That's what we know. But sir, this time, it is not GIF of x, it is GIF of x by 3. So this time, x by 3, whenever is an integer, let's say I'm taking that integer as a small z, where what is z? Z is an integer, right? So whenever x by 3 is an integer, yes, absolutely, Vijay, perfect. I hope you're getting it. X by 3 is an integer. GIF of x by 3 will be discontinuous. Getting it, everyone? Which means here, if I want to clarify, x will be 3 times z, where again z is nothing but an integer. But sir, mind you, x is any number between 0 to 30, including both. Okay. So if I put z as 0, I'll get x as 0. I'll put z as 1, I'll get x as 3. If I put z as 2, I'll get 6, and so on, 9, and so on. And ultimately what? The last value will be 10 into 3. That's 30, and that's where I stop, because 30 onward, I cannot take the values. As Vijay has also written in the comments, beautiful, beautiful, excellent. So did you all realize these are the points, which are the points of discontinuity? How many of you were able to crack it? How many of you were able to do it? Was everyone able to understand this? All the participants? Any queries or confusions if you have, please ask. Similarly, will you be able to do all the remaining questions? Yes or no? I'll get one more question done and then we'll move ahead. Third one I'm getting done. These two I'm giving you as homework. So this one you try by yourself at home. This one you try by yourself at home. Third one I'm getting done. So third one, if you wish to do, how are we going to do it? Let's talk about that. Everyone. Sir, for third one, I'll just ask you to do one thing. GIF of sine inverse x. Can somebody tell me the answer for GIF of sine inverse x? Anyone? How do we figure it out? Sir, GIF of sine inverse x is what you're trying to do. Yes, I am saying whenever sine inverse x is an integer, sir, if intervals aren't given, how do we get it? You know about functions. Like, yes, in that case, Ariman, all the multiples of 3 will be discussed. Yes, all real numbers where x is any multiple of 3 will be the points where it is discontinuous. So I'm saying sine inverse x is going to be an integer. Whenever it is an integer, that will be the point of discontinuity for this curve GIF of sine inverse x. Okay. Now, how do I crack it? I'll say if sine inverse x is z. Sine inverse x. Do you remember the graph of sine inverse x, students? In the ITF, we have discussed that this is how you draw the graph of sine inverse x. Remember that? So here, the values are, I hope you remember, minus pi by 2, 0, and pi by 2. So minus pi by 2 is approximately minus 1.57. Pi by 2 is approximately plus 1.57, and 0 is 0. So I am asking you, Vijay, check your answer once again. I am asking you that between minus 1.5 and 1.5, how many integers are you noticing? Sir, we are noticing 3 integers. One integer will be minus 1, one integer will be 0, and one integer will be plus 1. These are the 3 integers. Which means what? At these values, which 3 values, students? At these values, which 3 values? If sine inverse x takes any value as minus 1, 0, or 1, these are the values where GIF of sine inverse x will be discontinuous. But sir, we are not asking you the value of sine inverse x. We are interested in sine. We are interested in x. So if sine inverse x is minus 1, 0, or 1, x will be sine of minus 1 or sine of 0 or sine of 1. Sine we know is an odd function, so minus 1 comes out, so it gives you sine 1 but with the negative sign. Sine 0 is 0 and sine 1 is 1. So these are the 3 points. These are the 3 points. These are the 3 points. No, it is sine of minus 1, sine of 0 and sine of 1. So my answer is not minus 1, 0 or 1. No Vijay, no Aryaman. My answer will be sine of 1 is negative, 0 and sine 1. These are the 3 points where GIF of sine inverse x will be discontinuous. Everyone with me? Any queries? Have you comfortably understood it? Shall I now move ahead towards the next case? Again, we are given 3 examples. I have deliberately taken these 3, out of which I'll be getting done any one, and remaining 2 I'll give you as homework. Will you all try this? So if I begin with anyone if you take, let's say this third one. So what have we learned? What have we learned? Sir, signum of anything is discontinuous whenever that anything is 0. Whenever that anything is 0, which means x square minus 2x plus 3, if it becomes 0, for whatever value of x it becomes 0, it will be discontinuous at those x. Okay, Abdul, I'm not sure, but yes, it could be the answer. But I hope you all are understanding. Signum of anything is discontinuous when that anything is becoming 0. For what values of x it is becoming 0, that's what we need to work out. So there I'll say, here pay attention everyone, I think splitting the middle term, so x square plus 3x minus x plus 3 is equal to 0. So one of the roots will be minus 3 and another root will be plus 1. So these are the 2 values where it becomes 0, and at these 2 values, this will be discontinuous. It's not 1 and 2, it's minus 3 and 1. Everybody getting it? Everybody comfortably understanding it, processing it? Yes or no? All the participants. Or shall I explain it more clearly? Yes, Vijay. Beautiful. Let's do one more question here only. Try solving the second question. First question I'll give you as homework. So to solve the second question, what we need is signum of anything is discontinuous whenever that anything is 0. That means 2 cos x minus 1 is 0, which means cos x is 1 by 2. Which means cos x is 1 by 2. What is 1 by 2? Sir, 60 degree. So 60 degree means what? 60 degree means pi by 3. So do you remember general results? In a trigonometry, you study a chapter trigonometric equations. Can you help me? Cos theta is cos alpha, then theta is given by. Absolutely, Vijay. Good. Keep it up. So I hope you remember here cos theta is cos alpha, then theta is given by 2n pi plus minus alpha. So these are going to be all those points where signum of 2 cos x minus 1 will be discontinuous, where this n is nothing but what? An integer. Are we clear on this, whatever I have done so far? Everybody comfortably processing it without any confusion? Or shall I re-explain this? Everybody got this? Everybody comfortably getting it without any confusion? Yes or no? Let's take one more example so that you can understand it more clearly. Look at this example. Discuss continuity of this function fx, which itself has a limit. Sir, come on. Are you saying that there are 2 limits? Yes. Sir, what do you mean by 2 limits? By 2 limits, I am saying that first of all, this is not for continuity. This is for the simplification of this function, which means if you could simplify it by resolving this limit n approaches infinity, then you'll get the function. And after getting the function, you will talk about its continuity. So first of all, I am right now not very much interested in talking about its continuity. Right now, I am more interested in simplifying it. So let's simplify it. How do we do it? Sir, fx will be limit n approaches infinity. Now pay attention everyone. Limit n approaches infinity on which curve? X to the power 2n minus 1 upon x to the power 2n plus 1. Everybody getting it? Now the best thing which is happening over here is x to the power 2n can I write as x square to the power n. This x to the power 2n also can I write as x square to the power n. Now they did it because of a deliberate reason. What is that deliberate reason? If I could look at this x, I am dividing it into different zones. One case when x is between minus 1 and 1. One case when x is between minus 1 and 1. I'm not saying x is minus 1 or 1, when x is between minus 1 and 1. Second case, when x is either less than minus 1 or greater than plus 1. And the third case, when x is either minus 1 or 1. Sir, why are you thinking like this? And how are we going to think like this? You will be able to think like this once I'm done with this question, if you're not able to think like this. But it's a very direct phenomena which is clearly related to a to the power x. Now, what did I just say? I am saying, pay attention everyone. When x is taking any value between minus 1 and 1, when x is taking any value between minus 1 and 1, does it not mean that x square is taking any value between 0 to 1? When x is minus 1 or 1, then it clearly means x square is 1. And when x is either less than minus 1 or greater than 1, then it clearly means that x square is greater than 1. Sir, why are we really discussing it? Can you be more specific? I am about to culminate it. Have patience. Now, I am saying x square, depending on these three cases, when n approaches infinity, behaves differently. Sir, what do you mean by that? Let me take you through this part. I'll show it to you with a to the power x. This is the graph of a to the power x when base is greater than 1. This is the graph of a to the power x when base is between 0 and 1. And I hope you do understand. This is the graph of a to the power x when base is 1. Sir, what have you really done? Can you re-explain? Yes. I'll draw x-axis and y-axis as well so that you understand it more clearly. I hope you do remember that this is how it goes. I'm really sorry. This is how it goes. This is how it goes when you talk about a to the power x when a is greater than 1. This is how it goes when you talk about a to the power x when a is between 0 and 1. And this is how it goes when you talk about a to the power x when the base is 1. This point I hope you do remember is always 0, 1. This point I hope you do remember is always 0, 1. This point I hope you do remember is always 0, 1. Sir, why are we really discussing? We are discussing it because of a specific reason. Because when power, what is power here? X approaches infinity, a to the power x approaches infinity if the base is greater than 1. Which means, can I say y is equals to a to the power x, let's say limit x approaches infinity on a to the power x will be infinity if a is greater than 1, will be approaching infinity if a is greater than 1. Got my point? Second case, if the power approaches infinity, then a to the power x approaches 0. Which means if the base is between 0 and 1, a to the power x when x approaches infinity is 0. The next thing, if the base is 1, which means it is exact 1, So if it is exact 1, when x approaches infinity, sir, it clearly always remains one exact fixed value, which is 1. So if the base is fixed 1, exact 1, then a to the power x when x approaches infinity is 1. Everybody got it? Everybody understood this? Any queries or confusions? All the participants? Sir, why are we using or talking about this? We are talking about this entire result because we'll be using this data here in this question. Now come back to this question, everyone. Here, good to have you, Akshansh. Good to have you here. Will you be able to understand this? This is continuity and differentiability from 12th we are doing. Anyways, here I am saying very simple thing that this x square is base. The base is between 0 and 1, which is less than 1. And if base is raised to a power, which is of course infinity, if base is raised to a power, which is of course infinity, base is between 0 and 1. So a value which is small raised to power infinity huge approaches 0. So x to the power 2 to the power n will be 0. So it will be 0 minus 1 upon 0 plus 1. Got my point, everyone? Sir, when x square is 1, when the base is exactly 1, exact 1 to the power infinity is 1. So it will be 1 minus 1 divided by 1 plus 1. I'm writing all of this because of a reason so that when you revise it through notes, you understand it completely. Now the next thing. When x is either less than minus 1 or greater than 1, x square is clearly greater than 1. So base is greater than 1. So if the base is greater than 1 raised to the power infinity approaches infinity. So it is infinity minus 1 upon infinity plus 1. It is infinity minus 1 upon infinity plus 1. Sir, what do you do in that case? It is infinity upon infinity form. It is infinity upon infinity form. So, sir, how do we work it out? Infinity upon infinity. So, infinity upon infinity, try and understand. You can use L'Hopital or whatever. Let's say I'm getting infinity by infinity in this case. So, infinity by infinity form, how do I resolve? Can I use L'Hopital? L'Hopital means what? Derivative of x to the power 2n minus 1 will be what? Power 2n times x to the power 2n minus 1. Derivative of 1 is 0. Denominator is also what? Power 2n. X to the power 2n minus 1. What I have done is L'Hopital. Derivative of numerator upon derivative of denominator. So they both become same. They get cancelled because numerator and denominator are same. So if numerator and denominator are same, they both become same. I am saying that minus 1 and plus 1 will not matter when it's a very huge value. Something huge minus 1, something huge plus 1 is almost same. So something same upon same is 1. That's what I'm saying. That you could have done intuitively as well. Getting my point? So this is how we see it to be simplified. If you don't get it, I'll write it like this. This and this are getting cancelled, so it is approaching 1. So if I do it on the next page, I'll be, first of all, the question is not done. We have just simplified the function. 0 minus 1 upon 0 plus 1 is clearly minus 1. 1 minus 1, 0 by 2 is 0, so that's 0. And this is 1, so this will be 1. So I think it looks like Signum, sir. It looks like Signum. Can we draw the graph? Yes, we can. How? Let's do it. So this is how the fx looks like. So if I draw the graph, how will I draw the graph? Let's draw it. So there are some chunks, minus 1, 0, and 1. These are the some chunks where it matters a lot. What I'm trying to say is, although you don't have to draw the graph if you really want to talk about continuity, but I'm trying to show you through the graph so that you can understand it more clearly. If x is minus 1 or 1, it is 0. So if x is minus 1, it is 0. If x is 1, it is 0. Between minus 1 and 1, it is minus 1. Between minus 1 and 1, it is minus 1. Before minus 1 or after 1, it is 1. So before minus 1 or after 1, it is 1. So this is how the graph of f of x look like. Great, excellent. So with this, what do I say, students? What do I say finally? I'll say, sir, it is clearly discontinuous at 1 and 2 points. So it is discontinuous at 2 points. Which 2 points? Minus 1 and 1. Everybody understood the whole explanation. First of all, through limit, we simplified the expression and then we differentiated it. Now there comes a very beautiful function which is called Dirichlet function. Dirichlet was a mathematician. Yes, at 0 it is continuous. Good, Vijay. Dirichlet was a mathematician. He came up with a very amazing, very surprising, very, very beautiful function which he called the Dirichlet function. I am not sure whether we'll be able to see the Dirichlet function. I clearly doubt it, but let me see if we have this. I'll be very happy to show this to you. Dirichlet, if you ever see, tell me. The stuff operations, visualization, probability, inference, hyperbolic, geometry, custom colors, number theory, advanced, tone, with and hour. So Dirichlet, of course. And how do we write the definitions? Piecewise definitions can we create? I doubt. Because for that I'll have to work a lot. So here I cannot see it, but I'll try and draw it to you, for you. Dirichlet functions graph, if I try and draw it for you. Let me try and draw it. So let's say this here is the x-axis. And this here is the y-axis. Now, this is 0. Let's say there is a point 1 over here. On the left of 1, let's say there is a point 0.9. On the right of 1, there is a point, let's say 1.1. So I think in 7th standard, or probably after or before this, you must have studied this, that between any two points, there are infinite points. I am saying that even if I take, let's say, 0.0001 and 0.0002, there are infinite real numbers. There are infinite real numbers. Yes or no? And real numbers are what? Either rational or irrational. So I'll say there are infinite rational and irrational numbers between them. Dirichlet gave a piecewise definition where he said that, let's say, if x is rational, you say it is 1. If x is irrational, you say it is 0. Absolutely, Vijay. So if x is rational, you say it is 1. At 1.1, it will be 1. And just on the left of 1.1, let's say there is a number which I don't know, but it is an irrational number. So if that is an irrational number, let's say at that point it is 0. So I hope you're realizing the moment you see a rational, it will be 1. The moment you see irrational, it will be 0. The moment you see a rational, it will be 1. The moment you see an irrational, it will be 0. But are you realizing the more I zoom it in, the more rational and irrational numbers I'll see. The more rational and irrational numbers I'll see. So if I said that here there was a rational number and there was an irrational number, so between them there will be infinitely rational and irrational. So again it will fluctuate between 1 and 0. So 1 and 0, 1 and 0, 1 and 0. So don't you think, sir, don't you think that when you look at this graph, from a broader perspective, it may look like this, that if some part exists here, some part will exist here, then some part will exist here. But technically, even very slight difference if I take, very slight two numbers if I take, very small two numbers I'll take, there are infinite rational and irrational numbers over here. Which means between this domain also, in this zone also, it will fluctuate a lot between 1 and 0, 1 and 0, 1 and 0, 1 and 0. Yes or no? Are you getting my point, everyone? So from a broader perspective, yes, uncountable rational and irrational, oscillating. Yes, true, Vijay. Good, 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 good. So finally, if I wish to draw the graph, I hope you get my point that, sir, you will actually see two straight lines. You will actually see two straight lines. Although in reality, what is happening is if the point exists here, it is right there on the left of it or on the right of it, but not exactly there. If something is there, something will not be just below it. But just on the right or just on the left of it, there are infinitely many rational and irrational numbers. So again, it will keep on fluctuating. So from a broader perspective, if you see the Dirichlet function, from a broader perspective, if you see a Dirichlet function, where it is 1, if x is rational, where it is 0, if x is irrational, it will keep fluctuating between 1 and 0. So you may see that there are two parallel lines. Technically, it is not two parallel lines. It is fluctuating between 1 and 0. Correct, everyone? So it is fluctuating between 1 and 0. It is discontinuous everywhere. Sir, how can you say this? I am saying this is there is a point 1.1. So right on the 1.1 or right on the left of 1.1, there will be infinitely many countable or uncountable rational or irrational numbers. So its limits is not defined. On the RHL right hand side of 1.1, on the left hand side of 1.1, it is either 1 or 0, but it is oscillating, it is fluctuating. I'm not getting a fixed value. So neither its RHL or LHL is defined around 1.1, and if that is not defined around any real number, what I'll say it is clearly fluctuating, which means it does not exist, the LHL and RHL, which means what? Which means it is discontinuous. Let's say if I take a number root 2, irrational. So at irrational, it is 0. But on the right of root 2, on the left of root 2, there will be infinitely many rational or irrational, both sides. So it will again keep fluctuating between 1 and 0. So am I able to decide something? No. Which means discontinuous everywhere. Did you all get this? Did you all get this? This may be called a definition, but it is clearly false. Based on that concept, you will be asked questions like this, where rational and irrational based definition, piecewise definition will be given to you, and you'll be asked to solve this question. So one of your brain, one part of your brain will say that, sir, it is clearly discontinuous. But do you really think it is discontinuous? Don't you think that there could be a point where it could be continuous? Which point? Which point? I am saying that there could be a point where x and 1 minus x both could become same. Sir, we don't get it. Have patience, I'll explain. If x and 1 minus x both could become same, which means 2x is 1, which means x is 1 by 2. Sir, what is happening when x is 1 by 2? First of all, let's draw both of these curves. So x is a straight line, 1 minus x is a straight line. Both are straight lines. Both are clearly straight lines, yes or no? Yes or no, everybody. But at 1 by 2, when you approach this definition or this definition, when you approach 1 by 2, this also approaches 1 by 2, and 1 minus 1 by 2 also approaches 1 by 2. I repeat, when x approaches 1 by 2, this definition approaches 1 by 2. When x approaches 1 by 2, this definition approaches 1 by 2. So my point is that just at 1 by 2, I mean right there at 1 by 2, it will be continuous. Why? Because around 1 by 2, there will be infinitely rational and irrational numbers on both sides. But both of them will take me towards 1 by 2. Whether you talk about LHL or RHL, are you noticing it? Are you all noticing it, yes or no? Are you able to digest it, interpret it, comprehend it, yes or no? So I hope you got my point that just at 1 by 2, all the points on the left of 1 by 2, all the points on the right of 1 by 2, whether rational or irrational, they both will take me towards 1 by 2. So luckily, just at 1 by 2, it will be continuous. Apart from that, 1 by 2 plus 0.0001, this will be the point where it will be discontinuous. At all the other points, it will be discontinuous. 1 by 2 will be one single point where it will be continuous, where LHL, RHL in the value will be same. But right on the right of it, right on the left of it, it will be discontinuous. Can you comprehend this? Imagine this idea in your brain. Just keep zooming in, zoom in at 1 by 2. And you will notice that right at 1 by 2, you will see these three to be merging together, LHL, RHL and the value. But apart from that 1 by 2, all the other numbers will be the points where it is discontinuous. Everybody got my point, or shall I re-explain this? Yes or no? So I'll say that this is discontinuous for all x which are real except for one value which is 1 by 2. Did you all get this? Everybody understood this example? Very clear, very direct. Everyone, give me a response. If you're feeling confused, we'll continue. But I hope you're completely understanding whatever I'm trying to say or make you understand here at this stage. Now, this is a case where I want to talk about composite functions discontinuity. Sir, what do you mean by that? Let's try and learn it. Fx is a function, gx is a function. If somebody asks you continuity of f of x, you clearly say that at x is equal to 1, this is discontinuous. Yes or no? Yes or no, everybody? कुछ कोई कर रहा है क्या? आवाज किस चीज की आ रही है? किस चीज की आवाज आ रही है? Yes or no? Shall I repeat this? At x is equals to 1, fx will be discontinuous. Here for gx, at x is equal to 2, it will be discontinuous. So fx and gx are very well sorted. But if somebody asks you about f of g of x, then what do you say? Please pay attention, everyone. F of g of x is very interesting. First of all, please understand f of g of x will be given by what? Sir, f of g of x is a composition. So f of g of x will be f of g of x, which means g of x plus 1 upon g of x minus 1. Now, please pay attention, everyone. There are higher chances that you may make a mistake, a very silly mistake. That is exactly what I'm trying to highlight with this example. Pay attention, everyone. Here, gx is 1 upon x minus 2. So fog here will be 1 upon x minus 2 plus 1 divided by 1 upon x minus 2 minus 1. If I take the LCM and all, what I get is, pay attention, everyone, 1 plus x minus 2, yes or no? So 1 plus x minus 2 is what? X minus 1. 1 minus x plus 2. So minus x plus 2 plus 1 is what? Plus 3. So it will be 3 minus x. Everyone, please pay attention, everyone. Fog here is having this definition. So you may end up saying that, sir, fog will be discontinuous, or rather you may say fog is continuous everywhere. That means for all the real values of x except for a value of x which is 3, which is wrong. Fog indeed is discontinuous at x is equals to 3, but fog does not have the input x. Fog is actually f of g of x. So f is taking gx, which means gx should also be considered, which means the point where gx is discontinuous will also be the point where I'll say it is discontinuous. Where was gx discontinuous? So gx was discontinuous at 2. So I'll say it is incomplete answer. At 2 and 3, fog will be discontinuous. Shall I repeat this line? Now, sir, why? Why here? Because there is x, it is passed to gx, then gx produces an output which is used as an input, and then you define f of g of x. This is how it goes. So imagine this. This fog is defined for all the values of x? No. Sir, for all the values of x which are not 1? No. For all the values of x which are not 3? No. This fog, first of all, is defined for all those values of x which gx can accept. First condition. And also, this fog is defined for those values which f can accept. Gx can produce anything, but gx must not produce anything which f cannot accept. Instead of doing all this, what you could have simply done or said is, you really don't have to create fog. Understand my language. Sir, x can take any number, okay, but what can gx take? Gx can take any number, but sir, gx cannot take 2, because if you push 2 here, it will be 1 upon 0, which is not defined. Okay, so gx cannot take 2, yes. So gx can produce any number, yes, gx can produce any number. So can that any number be passed as an input to f of g of x? I mean, f can take any gx. No, sir. F cannot take a gx which is 1. F cannot take an input which is 1, because if the input provided to fx is 1, 1 minus 1 denominator will be 0. So here I'll say I'll avoid one more value where gx is 1. So two values will be avoided. Sir, when is gx 1? So if I want to check that gx is 1, so I'll say x minus 2 is 1, which means x is equal to 3. So whenever I wish to say that gx is not equal to 1, so I'm trying to say x is not equal to 3. So f of g of x will be discontinuous at the 2 points. You really don't have to do this. Did you understand this process, or are you still feeling confused? Everybody, give me a quick response, a quick confirmation. Are you all comfortable with whatever we have done so far? Any queries or confusions if you have, please ask. Vijay, did you get your answer? Whatever you're asking in the comments. All the other participants as well who are watching it sincerely, did you all get it? When composition comes into picture, how you think. There are two methods. You actually go by this process, or you think it like this. Both are fine. Everybody understood this or not? Give me a quick response. Now let's talk about differentiability. What is the meaning of differentiability? Let's talk about that. Let us say there is a curve and there are x-axis and y-axis. Yes or no? Great, perfect, brilliant. With this, let's say on this curve, there is a point x is equal to a. Or you can say x or a or whatever you want to call it. Let's say there is a point x is equal to a. Now, I change this x a little. I change this x a little. I change this x a little. So that change in x I'm denoting by del x. Del x means change in x. Great, great, Shubham, Ariman, Rimpi, Vijay, everyone. Perfect, brilliant. Now, when I make certain change in x, that is del x. So x, it was a. I'm moving on the right hand side of a. So this point here becomes a plus del x. Everyone getting it? So this point over here was a. I move del x rightward of it. So it becomes a plus del x. Sir, can you not move leftward of it? Yes, it will become a minus del x. It is perfectly fine. Left or right? Right now, let's say right. Sir, the graph is, let's say, y is equals to fx. Okay. So in that case, what will be the value over here? So the value over here will be this, which is f of a. Sir, what will be the value over here? The value here will be f of a plus del x. Now, what I'm trying to say here is a very interesting and a very amazing fact that if I join these 2 points on our Cartesian plane, sir, we are discussing calculus. Why are you bringing coordinate geometry? Let me do it. Let me do it. So if I join these 2 points, how does it look like? Sir, this looks like a secant to this curve. This looks like what? This looks like a secant to the curve. Curve means f of x y is equals to fx. Everybody understood this part comfortably? Now I start doing one thing. Newton and Leibniz, while developing calculus, gave you very interesting fact, which means we can play with the number if we introduce limit. Sir, what if I decrease this little? I mean, if decrease this del x, what happens in that case? So if I decrease it a little, it will come closer to it. So let us say I'm decreasing it a little. In that case, it has come closer. It has come slightly closer. So let's say I am decreasing it to this extent. Now let's say this is new del x. So as per that, this will be new a plus del x. As per that, this will be new f of a plus del x. I hope you're getting my point. So this This, let's say, and this has vanished. Now if I join these two dots, sir, again it is a secant. Again it is a secant. Yes, it's a secant. Okay, sir, can you make it little more closer? Yes, let's try to make it little more closer. In that case, let's bring it here. So this is that new del x. So this point here will be new a plus del x. So as per that, this point over here will be new f of a plus del x. So I hope this and this is not there. So if I join these 2 points, this is again a new secant. But are you noticing something? Yes, I'm taking dx in a while. Are you noticing something? What are you noticing? Sir, originally with that del x, it was a secant. But as I kept on decreasing that del x, if I kept on reducing that del x, that secant is gradually getting converted into a tangent. Have you noticed it? Have you noticed it? Let me try and show this to you. If I reduce the del x very close to a, let's say this is this minute difference which you can see right here, this minute difference which you can see right here is, let's say, that del x. So this point over here will be a plus del x. This is that del x, mind you students. So this del x and this a plus del x is not there. So based on that, if I just take it there, this point here will be f of a plus del x. So based on that, if I join both of them, it is almost a tangent. Yes, it becomes a tangent. At that point, I'll reach to a tangent. Absolutely. That's my whole point. What is my whole point? My whole point is f of a plus del x minus f of a, which is y2 minus y1 upon a plus del x minus a, which is x2 minus x1, where del x is kept as small as possible, reduced to as 0 as possible. I hope everybody is getting it. That you decide, my dear friend, unique soul, how can I compare these two good things, I'll say. So y2 minus y1 upon x2 minus x1, where this del x is approaching 0, I hope you are clearly noticing, is nothing but what? It is the slope, of this tangent to this curve. So I'm merging coordinate with calculus if you are able to get it. I'm coming to that point, Aryaman, but very good. Very good, you have defined it. Good, excellent. So what are you trying to say here? I am trying to say that when we make change in x, so correspondingly change in y also happens. Y means f of x. So when I start noticing change in x with respect to change in y, so if I start noticing, sorry, I said opposite, I think. When I start noticing change in y with respect to change in x, sir, what kind of change? Very small change. So if I'm making very small change in x, of course, very small change in y is happening. Of course, that change in y and that change in x is different. So you cannot compare those changes. But if x is changing very small, very slightly, then y is also changing very slightly. Although change in y and change in x could be totally different numbers. But I'm saying when x is changed slightly, y will also change slightly. But sir, if x changes, how does y change? If that I wish to observe, that means if I wish to observe change in y when x is changed, very little. That means I'll say spontaneous or instantaneous change in y with respect to very small significant change in x is this y2 minus y1 upon x2 minus x1, which Newton and Leibniz have reserved an operator for it, which of course we are right now calling as tan theta, which we are right now calling as slope of the tangent drawn to the curve at x is equal to a, or this whole phenomena by Newton and Leibniz is given by a very simple operator which is called dy by dx at x is equal to a. Which means what? Which means that if I differentiate a function, if I differentiate a curve, the ab initio method exists there, the first principle exists there, which I'll not be discussing because we are discussing it related to JEE only. So ab initio method here says that if you differentiate a function, geometrically it means you are getting tangent to the curve drawn to that at point, drawn to the curve at that point. Or algebraically it would mean that you are noticing the change in curve or f of x with respect to change in y, instantaneous change, spontaneous change, very rapid change. I mean, if x is changed slightly, what change y does, what change y brings, that change if you want to observe, that all can be done by dy by dx. Vicky is asking, sir, if we watched all your lectures, shall we crack JEE Mains in Advanced? That totally up to you, Vicky. I'm really not a good person to ask this question from, but I'll assure you of one thing. If you're really sincerely, consistently, regularly, in a disciplined manner watching all of these lectures, you will understand almost all the concepts of JEE Mains in Advanced. But sir, practice is needed. It is JEE Mains in Advanced ultimately. So I'm not denying it. Once you watch these lectures, you practice. So you begin with the last 6 years, previous years questions of JEE Mains, and then you move towards JEE Advanced problems. So last 20-25 years, JEE Advanced problems you solve. And that will help you totally in cracking JEE Mains Advanced. Even right now at this stage, if you start doing it sincerely, Vicky, you will be able to do it. Everybody got my point? Shall I move towards the concept of differentiability now? Now, sir, what do you mean by differentiability? Right now, I'm just trying to bring a very basic idea of differentiability where I'm trying to say that differentiability for me would simply mean geometrically, differentiability will be defined if you are able to draw the tangent. Sir, why? Because if a tangent can be drawn uniquely, its slope could be defined. Could be defined. I'm not saying not necessarily will be defined. Could be. I do remember you, Black Mystery. How can we forget you? So I am saying that if I can define a unique tangent whose slope is very well defined, the function at that point will be called differentiable. Did you listen to my words? If you heard me properly, every single word, if you heard mine properly, you would understand the exact meaning of differentiability. I am saying that let's say this is a curve which is discontinuous at A. This is a curve which is discontinuous at A. Give me a moment, students. Vijay, इसमें देखना pop-up आ रहा है एक. This is a curve which is discontinuous at A. So if I start looking at the right hand derivative and the left hand derivative, see, secants I'll begin with. So let's say this is that, then gradually this will be this, then gradually this will be this, this will be this, this will be this. So sir, ultimately when you reach to this point, from right and left hand side, secants you keep drawing, secants you keep drawing, secants you keep drawing. Don't you think here you are drawing totally different tangents, here you are drawing totally different tangents, and that too, sir, let's say even if you reach to a conclusion where you say that this could be the tangent, here at this stage you could say this could be the tangent. Are they same? Of course not. They are not unique. If the tangents are not unique, how can their slopes be? How can their slopes be unique? Absolutely. So I am saying whenever a function is discontinuous, it is non-differentiable. But I did not say converse, which means I did not say that if a function is non-differentiable, it will be discontinuous. No, I did not say this. If you are assuming it like this, that's your mistake. I am saying if a function is continuous, it will be differentiable. It may not be. Lovely, Black Mystery. Good to hear that. So you're pursuing MS from IIT Madras. Good to have. Good to in space technology and aeronautics. And parallel EC in Pondicherry. Is it really possible? Can a student do it? Can a student really do it? Yes, Ashok, you will definitely get more than 100 marks in your boards. Okay. By the way, Black Mystery, congratulations. Good to hear that, finally. Anyways, shall we get back to this discussion, everyone? So first of all, if the graph breaks, it is absolutely non-differentiable over there. Second condition, sir, in this case, it is continuous. Look at LHL, it is taking you there. Look at RHL, it is taking you there. Look at the value of the function, it is there defined. So LHL, RHL and the value of the function is same, which means it is continuous at A. Despite being continuous at A, I hope you do realize at A, can I really draw a unique tangent? Can I really draw a unique tangent? Don't you think? Infinitely many tangents can be drawn. So, sir, are you saying if I'm able to draw a unique tangent, it will be differentiable? I did not say this so far. If I said this, you didn't hear me properly. But I am saying that even if this function was continuous, it did have a sharp turn. And because of a sharp turn, first of all, discontinuous, second, continuous, but sharp turn, it got discontinuous, non-differentiable. So second reason is discontinuity, second reason is sharp turn. So sir, are these two reasons sufficient to say a function could be non-differentiable? No, I did not say this. There could be third reason as well. Can somebody explain this reason to me in the comments? Ashok Sharma is asking, sir, graph and equations, which are tough and easy. Ashok Sharma, can you be more specific regarding what are you asking this? Navant Patil is saying, sir, how can I clear my backlog? You can clear your backlog, Navant, by studying regularly. And if you want my help, I'll say on our channel PWJ English, there is a video which is titled as how to cover your backlog in the last 6 months before JEE Main's January attempt. Watch it. I have given a lot of insights on how to cover it. Trust me. Just watch it and thank me later. Absolutely, absolutely, Ariman. Whenever the function breaks, it is non-differentiable because a unique tangent cannot be defined whose slope is defined. But sir, in this case, this is a curve where at this point, I can define a tangent, and that's a unique tangent, sir, mind you. So, sir, you have always been saying that if a unique tangent can be defined, it will be differentiable. No, I was not saying this. It might be assumed by you, but I said unique tangent with a defined slope. And here, this is a unique tangent, but it is a vertical tangent. But it is a line parallel to the y-axis, which means its slope will be pi by 2. No, its inclination with positive x-axis will be pi by 2. So its slope here will be 10 pi by 2, which is clearly not defined. So this is that third case where you will find a function to be non-differentiable. Three cases. Discontinuity. Second case, sharp turn. Third case, vertical line. So if the tangent is vertical, function is again non-differentiable. There was a unique tangent, still it did not have differentiability here. It was non-differentiable here because vertical tangent. Did you all get all the three cases? Did you all understand all the three cases, all the participants? Now, sir, how do we really check the differentiability? How do we really check the differentiability? So, let's say this is a curve. This is a point, x is equal to a. So, if I move del x rightward, it will be a plus del x, or if I call that del x as h for a while, so this point will be a plus h. If I move h units left side, so this point here will be a minus h. So accordingly, this point over here will be f of a plus h. This point here will be f of a. and this point here will be f of a minus h. So you say a function is differentiable only when both of the secants from left hand side and the right hand side, if both secants start merging together towards one unique tangent whose slope is defined. I mean, I'll start creating secants from left hand side, I'll start creating secants on the right hand side of it, and I'll keep reducing this h as close to a as possible. And ultimately, if I get the same tangent, I'll say it will be differentiable. Which means to say whether a function is differentiable at a point A or not, its unique tangent must exist, defined tangent must exist. So from right hand side, tangent will be y2 minus y1 upon x2 minus x1. And from left hand side, the slope will be y2 minus y1 upon x2 minus x1. But sir, you're making a mistake. This is not a secant, it's a tangent. Yes, it's a tangent. So then I'll say here limit h approaches 0. Here also limit h approaches 0. That slight difference should be as small as possible. So this thing over here is called the right hand derivative. This thing here is called the left hand derivative. And if for a function its RHD and LHD are same, then we claim the function is differentiable at x is equal to a. Everybody got it? So if you want to simplify this, you can a little. How? A plus h minus a will be h, so you can write it as h. A plus h minus a will be minus h, so you're going to replace it by minus h. So that's also how you define LHN and RHL. Everybody got it? Everybody understood the concept of differentiability, LHL and RHL? Sir, yes, theoretically we are still a little bit confident, but can you really explain it through some examples? Let us take some examples. Everyone, are you all there? Here, this question here asks you to figure out or talk about differentiability of this curve at 0. Okay. So sir, for continuity, what we used to check was LHL, RHL, and the value of the function. If these three all were turning out to be same, then we used to say it as continuous. But for differentiability, we need just two things, LHD and RHD, left hand derivative, right hand derivative, and they should be same. Getting my point? So if I now begin with this particular part where I'm talking about the LHD, LHD around 0. So LHD around 0 means what? LHD means what? Left hand derivative means limit h approaches 0, f of a plus h, but what is a? 0. So f of 0 plus h minus f of a, which is f of 0, upon 0 plus h minus 0, which is h. I hope you're getting it. Limit h approaches 0. H is a very small positive quantity. F of 0 plus h, f of 0 plus h, which means f of h minus f of 0. So f of 0 is 0. Divided by what? Divided by h. Limit h approaches 0. F of h. Sir, f of h. H is not 0. H is approaching 0. So it is something very small close to 0, which means non-zero. So f of h will be sine x square upon x. And the whole thing, I'm really sorry, it's not sine x square upon x. It is sine h square upon h. And this whole thing is divided by h. So I hope you're realizing this is that bigger division. So it is h upon 1. So it is sine h square by h square. So this is limit h approaches 0, sine of h square by h square. So when h approaches 0, h square also approaches 0. So sine 0 upon 0 is 1. So left hand derivative we have received as 1. Now, let us talk about the right hand derivative. Sir, right hand derivative. I'm really sorry, I made a mistake. It is right hand derivative. I don't know why did I write it. It is right hand derivative. Now I'll be writing LHD. I'm really sorry if you got confused. Now I'll be writing LHD. LHD will be limit h approaches 0, f of a minus h minus f of a upon a minus h minus a, which is 0 minus h minus 0, which is minus h. Getting it, everyone? Now, LHD will be limit h approaches 0, f of minus h, f of 0 is 0, and minus h is minus h. Getting it, everyone, comfortably? Now, f of minus h, f of minus h. Sir, h is a very small positive quantity. So f of minus h will be something non-zero. Something non-zero will give you this. So it will be sine minus h square, which means h square divided by minus h. Whole gets divided by minus h. So minus h, where of course limit h approaches 0 is what you need to apply. So I hope you're getting it. In the numerator, it is sine h square. In the denominator, it is minus h into minus h, which is again h square, where limit h is approaching 0. So again, it is clearly 1. Which means what? Sir, this means left hand derivative and right hand derivative are same. So I'll say it is differentiable at x is equal to 0. Did you all get it? Did you all understand it? Have you all been able to digest it? Any queries or confusions if you have, please ask. Shall I move ahead if you have gotten that part, the previous part? Let us take a 10 minutes break and then we'll resume. Is that okay? 10 minutes break and then we'll continue with this question. You also take a break, stretch a little, and then we'll resume. Okay, so come back everyone. If you all can hear my voice, if you all can see me, come back everyone. I hope some of you must have tried doing this question. Can you all hear me? Can you all see me? Can you all see the screen right there in front of you? Everyone. I hope you do remember that we are doing continuity and differentiability today, which means today we have already previously covered limits and we are extending it into continuity and differentiability for your JEE Mains. And this is a free batch, free one-shots for you, which you have brought, and you get PDFs as well. Everything is given in the description as in the pinned comments as well. If you explore it, you will get it. I'll come back to the conversation we were having before the break. How do we talk about this part? Can you all hear me? Can you all see me? Everyone come back if you all can hear my voice. I hope you had a break. You must have hydrated yourself. You must have had something. You must have stretched or walked around. Now sit back and start rewatching it again. Aryaman is saying, what do we do at the endpoints? Of course, at the endpoint as continuity, we check the differentiability from either ends only. Either means, let me explain that part as well through an example. Let's say this is the curve. So this is a point A. This is a point B. So between A to B, if I wish to check the differentiability, so it should be differentiable at all the points between A and B. But at A, it should be left-hand differentiable. And at B, it should be only right-hand differentiable. If that is finite that exists, then I'll say it is differentiable in closed interval A to B. Everybody got this? Everybody? I think that's exactly what you were asking, Ariman. Okay, good with Ved. Excellent. So I'm sure by the time I was out on a break, some of you might have tried solving this question. So how do we really do it? Shall we, everyone? Here comes a very interesting part, which says that, sir, f of x has three definitions. When x is less than 1, a quadratic. When x is between 1 and 3, a linear. When x is greater than 3, a quadratic. So we know that linear, quadratic, trigonometric, inverse trigonometric, exponential, logarithmic, polynomials, they all are very smooth curves. So they are clearly differentiable in their domains. So between, less than all the values of 1, a quadratic will be differentiable. Sir, between 1 and 3, linear will be differentiable. Greater than 3, a quadratic will be differentiable. So I don't have to check it for the values which are less than 1, for the values which are 1 and 3, between 1 and 3, for the values which are greater than 3. I rather need to check its differentiability at these points where it is taking these transition points. Let's read the question. Find the values of constants A, B, P, and Q. So that all the following conditions are satisfied. It is continuous for all x. Okay. F-1 does not exist, so I need to ensure that it is not differentiable at 1. And f-x is continuous at 3. So these three conditions are to be matched. I'll solve it one by one. So let me begin with this. First part, if I could solve. The first part here says, great, some of you have started responding. That's brilliant, students. Keep it up. Really good. Reenu Thakur and everyone. Fx is continuous for all x. If it is continuous for all x, sir, two things should be fulfilled. F1 minus F1 and F1 plus. Left hand limit at 1, right hand limit at 1, and the value at 1 should be same. It will be continuous at 1. And the second thing, F3 minus F3 and F3 plus. That means left hand limit at 3, value at 3, and RHL at 3. It should be same. Remember that, students? Based on that, if I could solve the first part. So first part, if I could solve F1 minus. So less than 1 if it is. 1 minus 1, that's 0. 0 into A is 0. 0 plus B is B. So at 1 minus, it is B. F1 minus is B. Now I hope you to realize F1 and F1 plus, both will be same. So f1 is 1 minus 1, 0. f1 plus is also 1 minus 1, that's 0. So I could crack that B here is going to be 0. If it is said to be continuous everywhere, I needed to ensure that B remains 0. Everybody got this? Sir, apart from that, we had one more condition where it is continuous at 3 as well. I mean, it is continuous everywhere, but I'll be checking it specifically at these transition points. So I'll be checking it at 3 and 1. I hope you're getting it. So at 3, if I check 3 minus 3 plus in 3. So 3 minus, I'll get from here. So 3 minus 1, that's 2. So left hand limit at 3 is 2. Value of the function at 3 is also 2. But value of the function right hand limit at 3 will be this, which will give you, pay attention everyone, 3 square into p, which is 9p, plus 3 into q, that's 3q plus 2. Everybody got it, or shall I repeat it? Left hand limit is 3 minus 1, that's 2. Right hand limit is 3 square into p, that's 9p. 3 into q, that's 3q plus 2. And if 2 and 2 are cancelled, I think I get 9p is plus 3q is equal to 0. One more thing I could do, that I can take 3 common. So it will be 3p plus q is equal to 0. It will be 3p plus q is equal to 0. Or you could have said q is equal to minus 3p if needed. So sir, one more result we have gotten, but is it sufficient? Absolutely not. Then sir, what do we do? I think we are given some more constraints. We are given some more conditions. Good, Vijay. That's brilliant. Sir, what are other conditions? So I have used first conditions. Second condition, f-1 does not exist. Means derivative of this curve at 1 is not there. Okay, let us try and interpret it. If it is continuous everywhere, then you don't really have to check its differentiability by doing that LHD and RHD thing. No. I am saying if it is continuous everywhere, then its differentiability can be checked by simply differentiating the curve in different intervals. It is ax square minus ax. Derivative of ax square is 2ax. Derivative of minus ax is minus a. B is already 0. Anyways, derivative of b will be also 0. X minus 1, derivative is 1. I hope everybody is listening and understanding without getting confused. And here the derivative will be 2px plus q. 2px plus q, but we really don't need it. I need only one condition, that f-1 does not exist, which means x is less than 1. This is x greater than equal to 1 and less than 3, equal to 3 as well, and this is x greater than 3. So I am told f-1 does not exist. Listening and understanding, everyone. So sir, if somebody says that f-1 does not exist, first of all, did you understand the differentiation part? Ax square became 2ax, ax became a, b became 0, x minus 1 became x, means 1, 2px plus q, derivative. So I am told f-1 does not exist, which means f-1 minus and f-1 plus should not be equal. LHD and RHD are not equal at 1. It is non-differentiable at 1. Getting my point, everyone? Which means what? F-1 minus. So this will give me F-1 minus. So 2a into 1, that's 2a minus a. That's F-1 minus. F-1 plus is 1. 2a minus a is a, so that leaves you with a as 1. So one more value we have worked out. What was that? That sir, a is not 1. A is not 1, because if a becomes 1, it will become differentiable at 1. So to ensure that it is non-differentiable at 1, a should not be equal to 1. Everybody got this part? Now sir, one more thing we are told. The third thing which we are told is that f-x is continuous at x is equals to 3. So f-x is continuous at equal to 3, which means f-3 minus f dash 3 and f dash 3 plus, it should be equal. Let's imagine f dash x is a function. And if f dash x is a function, they are saying that f dash x is continuous at 3. So 3 minus and 3 plus should be same. What is 3 minus? So 3 minus is 1. The value at 3 and RHL at 3 will be same. This is this 2px plus q. So x is replaced by 3. 3 into 2, 6. So this will be 6p plus q. One more value I have received. Everybody getting it? Any confusions? So what I'll say now is that, sir, q was minus 3p. Q was minus 3p. So if this q replaced by minus 3p, 6p minus 3p is 1, which means 3p is 1, which means p is 1 by 3. So if p I receive as 1 by 3, if p I receive as 1 by 3, q we receive as minus 3 into 1 by 3, which is minus 1. So have we cracked almost all the values? I think whatever we could, we have. We know all these values a, b, p and q. Sir, a can be any real number but not 1. B has to be 0. P has to be 1 by 3 and q has to be minus 1. Everybody understood every single step which we have performed? Yes or no, all the participants? Are we comfortably getting it? I hope the concept of differentiability is not confusing at all. You are comprehending it totally and absolutely without feeling confused, without getting confused, all the participants? Yes or no? Now, different theorems are there based on two functions when they are added, subtracted, multiplied or taken their division, based on them being differentiable or non-differentiable. The way we have discussed different theorems on continuity, in the same manner, different theorems on differentiability also exist. Sir, what are they really? Let's go after them one by one. I'll begin with the first one. So let me read it for you first and then I'll explain. fx and gx are differentiable functions. Then their sum, difference, product and quotient will also be differentiable. What does it mean? It means, let's say there is a function sin x which is absolutely differentiable. Let's say there is a function ln of x. This is also differentiable. So if sin x and ln x are differentiable, then their sum, difference, product. I hope, how do you write sum, difference? This is sum. Difference will be sin x minus ln of x. Product will be sin x into ln of x. And division will be sin x divided by ln of x. They all will be differentiable. Good, Subhash. The only condition which I'll take care of is that, sir, here we'll avoid keeping ln x to be 0. I mean the values of x where ln x is 0, those values are not included. That's, I think, understood. So I think it is absolutely relatable from continuity. The concept in continuity, what did we discuss? If two functions are continuous, their sum, difference, product and division is also continuous. The same theorem gets extended here in differentiability. If two functions are differentiable, their sum, difference, I hope you're getting it, their sum, difference, product and division is differentiable. In division, it should be taken care that denominator we never keep 0. Now, one again very beautiful standard direct concept, that if two functions are given, for example, I hope you clearly know that let's say one of the function is x, or let's say any function I take, let's say e to the power x, another function is mod of x. So e to the power x is differentiable for all x which are real. It is non-differentiable at x is equal to 0. I hope you understand. Mod x takes a sharp turn at 0. That's why it is non-differentiable at 0. So there is a function which is differentiable at 0. There is a function which is non-differentiable at 0. So what about their sum? What about their sum? So sir, whether you take their sum or difference, this will be non-differentiable at x is equal to 0. Everybody got my point? Everybody understood my point? Are you all comfortably getting it, all the participants? Great, great, perfect, brilliant, good students. That's good. But there comes a very interesting fact that if both of the functions are non-differentiable, then there's some difference, product, division. I don't know, sir. I don't know, which means it can be differentiable, it cannot be, we just don't know. Let me take some examples. Let me begin with this one. Fx is mod of x minus sine of mod of x. Sine of mod of x is non-differentiable at 0. Mod of x is non-differentiable at 0. What about their difference? We'll have to work it out manually. What about their sum? We'll have to work it out manually. Mod of x into signum of x. Signum of x is discontinuous at 0, so non-differentiable. Mod of x is continuous but sharp turn at 0, so non-differentiable. So both of them are non-differentiable at 0, but their product, I don't know. I'll have to work it out manually. I hope you are getting my point. You are understanding my point. Sir, whatever you have said so far, can you explain it with a table? Okay, I will. I am saying, let's say there is a function fx, there is a function gx. Now I want to talk about their sum. I want to talk about their difference. I want to talk about their product. I want to talk about their division regarding differentiability on the parameters of differentiability. So fx is differentiable, gx is differentiable. Similarly, I'll take it, don't worry, Ariman, I'll take it and I'll explain it, don't worry. So f plus g, f minus g, f into g, f by g will be differentiable. F by g means g should not be 0. Those values of x should be omitted. Sir, what if f is differentiable, g is not? In that case, f plus g and f minus g will not be, but f into g and f by g I need to solve. And with that, I want to highlight something really important, that there is a rule which is something related to continuity only, which we have discussed in continuity. The same kind of rule we'll discuss here. I'll explain that in the upcoming slides, don't worry. Now the third rule, again same as this, fx is non-differentiable, gx is differentiable. Their sum and difference will be non-differentiable. Their product and division will be non-differentiable or differentiable, I don't know. But again, with the product and division are almost same. Fx you multiply by gx, or let's say here you say fx multiplied by 1 by gx, so technically it is product. So with the product, there is a simple exception. I mean, there is one additional rule which you should take care of in mind, which I'll explain very soon. But right now, we just don't know. When one of them is differentiable, other one is non-differentiable, their product or division, I just don't know. I'll have to work it out manually. Let's say, sir, both of them are non-differentiable. Then addition, subtraction, product or division could be differentiable, could be non-differentiable. I'll have to figure it out manually. Ariman is asking, sir, what do you do with e to the power mod x? So are you asking that e to the power mod x, whether it is differentiable or not? You can do it within seconds if you know transformation of graphs, Ariman. Can you help me with the graph of e to the power x? I hope you do remember, this is how you draw the e to the power x. So e to the power mod x, if you wish to draw, what you'll do? Sir, for e to the power mod x, this part stays like that. You just take this part also. I mean, its mirror image also. And I hope you do see there is a sharp turn here. There is a sharp turn here. If you're not getting it, I'll explain it with this simple example. Let's say here we are trying to draw y is equals to, where is e? Exponential to the power. Look at this. This is what I'm trying to talk about. Ariman, did you get it? There is a sharp turn. So if you know transformation of graphs, you can do it within seconds. Although with the LHD and RHD also you can do it. But if it's simply a question in IDJ, you really don't have to do it. You use your brain and get your answers, right? Coming back to the discussion we all were having. So I was explaining something really crucial regarding this. What? I am taking you through that. Let me take one example. Here comes that part. First of all, as I've told you, one is differentiable, other one is non-differentiable. Then their product can be differentiable, cannot be differentiable. But sir, how do we How do we really see that exception rule, that where we don't really have to work it out? The rule says that special case, we call it. I think you remember that in continuity also we have discussed that special case. What is that special case? Fx and gx are continuous at A. Fx and gx both are continuous at A, where f of A is 0 and gx, whatever it is, differentiable or non-differentiable, I don't care. Gx, whatever it is, differentiable or non-differentiable, I don't care. But in that case, fx into gx, without even checking, I can say will be differentiable. Sir, what have you just said? Can you be more specific? I'll take some examples to make it more understandable. For example, which one shall I take? This one I'll take. X minus 1 log x, let's say. Here I'm taking an example. Let's say x minus 1 times ln of x. Now, let's say this is fx, this is gx. First check which you apply is continuity. Are both of them continuous? Yes. Mod x minus 1 is continuous. Log x is continuous. I hope you do get that. I hope there is no confusion about them. Okay. Sir, what about differentiability? Sir, in differentiability, mod x minus 1 is non-differentiable at x is equal to 1. But this is clearly differentiable at 1. It is differentiable at x is equals to 1. It is differentiable at any real value of x technically. But this fx at x is equal to 1, which means here I'll say, is it visible to you all? Let me write it here. And one very interesting thing which it shows is that f of 1 I find 0. That is ln of 1 at base e we see to be 0. If these three conditions are fulfilled, this is that special one. If these three conditions are fulfilled, both of them are continuous. This one, whether differentiable or non-differentiable, I don't care. But if this one is differentiable at x is equals to 1 and it is becoming 0 at 1, then if at 1, even if it is non-differentiable, non-differentiability into differentiability becomes differentiability if this was 0. How many of you did not understand it? Tell me. Let me know, I'll re-explain. If you remember, we had a discussion on the same concept when we were talking about continuity. You would be able to relate it with that concept. If you have forgotten it from there, I'll make you recall it one more time. In continuity, what did we discuss? Sir, if there are two functions, one is continuous, other one is discontinuous, their product is done. So product can be continuous or discontinuous. But if the continuous function becomes 0, where the discontinuous function is becoming discontinuous, then the product will be continuous. I hope you do remember, I am simply saying this thing that let's say there is a curve sin x into, let's say, signum of x into. So I am saying sin x is continuous for all x which are real. Signum x is discontinuous at x is equal to 0. But the point where it is becoming discontinuous, at that point, is this becoming 0? Yes. Let's say this is fx and this is gx. So I know that f of 0 is 0. So the point where it is discontinuous, at that point, this is becoming 0. So 0 into discontinuity becomes continuity, which means this will be continuous at x is equal to 0. The same fact applies here in this part as well. Do let me know in the comments whether you are getting it or not. I am saying this is continuous, this is continuous. This is differentiable, this is not differentiable. But the point where it is non-differentiable, it is becoming 0. So 0 into non-differentiability becomes differentiability. Did you get my point, or shall I re-explain this? If you don't get it, I'll explain it with one example. Let me try and show you this graph. Pay attention, everyone. Let's say if I just draw this curve, y is equals to mod x minus 1. I hope you do accept it. That, sir, y is equals to mod x minus 1 will simply, did I make any mistake? Y is equal to. So this is clearly a curve which is having a sharp turn at 1. Absolutely non-differentiable. But if I multiply with a function which is differentiable at 1, and 0 at 1, a function which is continuous at 1 but non-differentiable at 1, when multiplied with a function which is differentiable and 0 at 1, this product will become differentiable. That's what I'm saying constantly. Are you able to get it or not? Tell me honestly. All I'm saying is, let's say if I multiply it by any function, let's say I'm taking log, let's say I'm taking sine of pi x, Now, previously it was non-differentiable at 1. But look at this case now. At 1, what a smooth curve it is. What a clear smooth curve it is. Yes, Vijay, mod x minus 1 was not differentiable at 1. But the moment I multiply this mod x minus 1 with sine pi x at 1 is 0 because it is sine pi into 1. Sine pi is 0. And that's why, or where I'll say that it is a differentiable function now. Did you all get it, or shall I re-explain this? So what is my whole point here at this stage? What I'm trying to explain you constantly. I said, let's say I have mod x minus 1 multiplied by sine pi x. So this function is continuous for all x which are real. This function is continuous for all x which are real. This function is non-differentiable at x is equals to 1. This function is differentiable at x is equals to 1, and it is 0 at x is equals to 1. So I'm constantly trying to tell you that 0 into non-differentiability becomes differentiability. Have you all gotten it? Have you all understood it? Or are you still feeling confused? Sir, why are you emphasizing so much on this theorem? Because this theorem you will be using at a lot of places in IIT JEE. When you're solving a question, specifically for IIT JEE, you would see this. Whenever product of two functions is given, where one function is continuous, other is continuous, one is differentiable, other is non-differentiable, but the one which is differentiable is 0 at the point where other is non-differentiable, the product will be differentiable. You can do the question by just looking at it. You really don't have to solve anything. You really don't have to write anything. If you are just noticing this property getting applied. Did you all get it? Did you all understand this? If you all have understood this, the theorem, let us solve a question, everyone. How simple this question is. Sir, mod x is non-differentiable at x is equal to 0. Mod x minus 1 is non-differentiable at x is equal to 1. It is non-differentiable at x is equal to 0, but it is differentiable at x is equal to 0. It is non-differentiable at x is equal to 1, but it is differentiable at x is equal to 1. Are you listening and understanding? So if I check the differentiability at 0, sir, it is non-differentiable at 0, but it is differentiable at 0. So non-differentiable plus differentiable is non-differentiable. So my first verdict will be non-differentiable at x is equal to 0. Second thing, it is non-differentiable at 1. But sir, this is differentiable at 1. So differentiable, non-differentiable, sum is Non-differentiable, Vijay, sum is non-differentiable. So it is non-differentiable at 2 points, 0 and 1. People in boards will, I don't know whether their syllabus allows these theorems or not, but somebody would do LHD, RHD, simplification, piecewise definition, everything. You can do it within seconds if you just know these theorems. If you just are aware of these theorems. Getting my point, everyone? Yes or no? Shall we try some more questions, everybody? Final question for the day, with which we'll be done with continuity and differentiability. And then in the next class, we'll discuss method of differentiation, MOD. So here comes the final question for the day. Let's see how many of you are genuinely able to do it. Shall we, everyone? What does the question say? So the question here says few things where fx is given by this definition and it is the real valued function, then the number of points where fx is non-differentiable is. Where fx is non-differentiable is. Okay. So I want to talk about non-differentiability. Yes, sir, we want to talk about non-differentiability. So first of all, my point of matter of concern will be 1. Because at 1, it is changing definition. So I need to, it could be discontinuous. So if it is discontinuous, it will be non-differentiable. So 1 could be that point where I should suspect, where I should stay doubtful. Okay, I'll check at 1. But before concluding that I'll check at 1, shall I not check it for all those values which are not 1? Because whenever x is not 1, this is the definition. So if x is not 1, which means all the real numbers except for 1, this is that definition. So it could also be non-differentiable. So let's forget the whole question. Let us simply solve this part. Let's say I am given a totally different question, which is defined as, let's say, hx, which is defined as hx or whatever it is, which is given by x minus 1 whole square into sine of 1 upon x minus 1 minus mod of x. Listen, this is a function where it follows a definition that x can be any real number except for 1. So at 1, it is not defined, let's say, as a function. This is a function, let's say, and I want to talk about its differentiability. Sir, how do we talk about its differentiability? I'll say, let us go ahead with one basic idea. Absolutely, Vijay. LHD and RHD at 1, I'll find that I'll definitely do. But before doing LHD and RHD at around 1, shall I not check that apart from 1, where can it be discontinuous or non-differentiable? Those points should also be considered. Of course, sir. So I am saying here, please pay attention, everyone. This function, sine 1 upon x minus 1, sir, x minus 1 will create a problem if x is 1. But x is already not 1. So I am not concerned about that. So x is any value but 1. It means it is never 1. We have already excluded 1. They have already excluded 1. 1 you really need not bother about. So sir, apart from that, where can it be discontinuous? Non-differentiable. Discontinuity, I think, is not a problem here. Non-differentiability is what we are trying to figure it out. So I'll say that, sir, let us look at it from the perspective of two functions which are getting subtracted, one function minus other function. So what we know is if this function is non-differentiable somewhere, this function is differentiable at that point, difference will be non-differentiable at those points. Good evening, Jagrati. If this function is non-differentiable at some points, but it is differentiable at those points, the difference will be non-differentiable at that points. And if both of them are non-differentiable at some point, let's say 3, just to understand you, make you understand you, I'll check it manually by myself at 3. Understanding my point? Yes or no? So let us use that logic. Let us first of all again break it further. So I am now looking at this curve, this curve, right? So let me break it into one more curve where I am now looking at this curve only. Just give me a second. Mod x I'm forgetting for a while, and this is the another curve I've taken, and I want to check the differentiability of this curve. Shall I? Now we are going to check the differentiability of this curve, everyone. Sir, this curve, when you want to check its differentiability, I think it's clearly a product of two curves, where the only problem I see is sin x is differentiable everywhere, yes or no, except for it is differentiable everywhere except for 1, because at 1 sine will become discontinuous sine 1 upon something. Here, sir, this is, of course it is continuous. It is continuous for all x which are real. 1 is already not there in its domain. Yes or no? Yes or no? But sir, this x minus 1 is a quadratic technically, so it is continuous and a differentiable for all x which are real, that is 1 as well. And at 1, this is 0. At 1, x minus 1 whole square is 0. So are you not realizing the property getting applied? Sir, which property? Which property, students? Tell me. Property where this is non-differentiable, but this is clearly 0. So 0 continuous and differentiable, 0 into non-differentiability is technically, I hope you are realizing my point, is clearly differentiability. So sir, if I was concerned about its differentiability at 1, it is differentiable at 1. Apart from that, it is differentiable everywhere. So I'll say it is differentiable for all x which are real. What about mod x? Sir, this is differentiable for all x which are real, but mod x we clearly know is non-differentiable at x is equal to 0. Because at 0, mod x is non-differentiable. Getting it, everyone? So I hope you realize differentiable at 0, non-differentiable at 0, their difference is done. So sum or difference of differentiable and a non-differentiable is non-differentiable. So I repeat, this part is clearly non-differentiable at x is equal to 0. Everybody got my point, or shall I re-explain this? But sir, x is equal to 1 could also be a point. It is not. Sir, why? Because it is differentiable at x is equals to 1. Yes, it is differentiable at x is equals to 1. Sir, why? Because at 1 this is becoming 0. So 0 into non-differentiability is differentiability. So this whole thing, differentiable at 1, difference will also be differentiable at 1. Getting my point? Apart from that, if I want to check it at 1, I think we have already concluded at 1 it is differentiable. Yes or no? Everybody got my point, or are you still feeling confused? So only one point, which is 0. Everybody got it? Any confusions or queries if you have, please ask. If there are any doubts or concerns if you have, please ask. Otherwise, we'll call it a day. Summary is simple. We have done limits in the previous one shots. Today we are done with continuity and differentiability. Now my only request is solve PYQs. Begin with means PYQs. Solve 2021 onward or 2020 onwards. And when you look at 2026 and when you look at JEE Advanced PYQs, begin with 2000 onwards. So 2000 to 2026, last 26 years PYQs of JEE Advanced you should be able to do. If you're really doing it, trust me, when you ask this question in the comments, sir, whether we will be able to do it or not, whether we'll be able to crack JEE Mains and Advanced or not, you would be if you're sincerely attending these lectures, watching these concepts, getting everything clearly, and solving these questions. So shall we call it a day here, everyone? Did you all get a decent, crystal clear clarity on this, whatever we have done today? Any queries or concerns if you have, please ask. Otherwise, I'll call it a day. Shall we? Do you have any doubts? Yes, we are done. So shall we end this session here, everyone? Okay. So we are done. Thank you so much. Solve previous year's questions. Yes, it's over. Thank you so much. You have been a great audience. Take a good care of yourself. Good night, everyone.